All right, while we're waiting, just go ahead and take a picture of that. This is the Boston chapter, LinkedIn. The second one is a LinkedIn post. So underneath that, you can talk about your interest, advertise your company, or advertise your projects, and then of course the WhatsApp group for Boston chapter. How many people created your own agent on join39.org? That's pretty good. You should thank Maria for setting up that page. You're going to hear from her. Everybody got it? You can take a picture now and then continue later on. All right. So I'm going to talk about what is NANDA, Network AI Agents in Decentralized Architecture, and we could be in a world where there's exactly one diabetes agent for the whole world, right? There's exactly one financial advisor for the whole world, just one math teacher for the whole world. Because if you have a highly centralized model that's so much more amazing than everything else, what's the point of having individual models or individual humans that claim they're smarter than that model, right? So we could be living in a world very soon where we are just intelligence slaves. At some point we had calculators and we kind of gave up on our, like if I gave you, a 3-digit multiplication, I would not trust you. I would just trust the calculator. And is a student going to teach a math teacher or just going to trust this massive AI model that's going to teach them math really well and keep it very engaged and personalized? So, so we could be living in a world where, we don't really have much creativity left. And although, as you know, AI will displace skills, it's not about jobs, right? So even if everybody has jobs, we could be in this intelligence slavery with not much creativity that we do. Like, if you look at my life today, I wake up in the morning and most of us, like I spend like a couple of hours on email, and that's my contribution to the world. I send out some emails and I feel like I have achieved, a lot, right? Once in a while, I get to have fun like this and come give a talk. But, and for a lot of us, a lot of knowledge workers, that's our life, right? We interact with digital information. We think we're contributing to the society and we are proud of what we are doing. But we could be living in this highly centralized AI world that most of the world have not much to do, even if they have jobs. But this is the problem with, again, a centralized AI model. And that's like the mainframe era of AI. You have seen this slide before. Moving to soon we'll move to the PC world, PC era of AI, where things will move on the edge. They stop renting AI models. We just own them, just like I own PowerPoint and just download it. I don't pay Microsoft every day for the slides I'm making. And then from intranet, which is where most of the enterprise scenario is, so we heard from Sudheesh, to the internet of AI agents to the World Wide Web. And the internet was about connecting machines. World Wide Web was about connecting people. And NANDA is about connecting agents. So again, we want to kind of imagine this millions, billions, trillions of AI agents. And we feel we're going to these 3 phases. In the beginning, it's about our identity, authentication, something that Sudhir talked about. Then when we move to a city, we get jobs. We start trading our skills for money. But over time, we build stock markets. We start creating companies like Groupon, where we have collective bargaining and so on. So the agents are going to do all these things for us. And they may not just help with our stock exchange. Agents will run their own stock exchange because there'll be in a decentralized world, when they're running on the edge, there could be millions of diabetes agents now that you have to choose from. And then again, when we move to a city, it's not just about our identity and our jobs, but we also, live in a society. We create organizations like these, create universities, we create justice systems. There'll be casinos, some good stuff, some not so good stuff. People create religions, and so on. So agentic societies will also emerge, not because they just want to socialize, but that's how they become better. That's how they become stronger. That's how they become more intelligent. That's how they can transact with bigger things. So I think we're going to go through these 3 phases very quickly, maybe in the next 5 years, maybe 3 years, I don't know, maybe even the next 2 years. So very briefly, I'm going to talk about The why, the what, and the how. The why is I'm going to make an economic argument. For the what, I'm going to make a social mission argument, and then the tech, the how, right? To how about the open agentic web. The why, why onset of the agentic web is, first of all, is there a, what if the group think on AI infra buildup is actually wrong? If this model start running on edge devices, and we have edge AI, local models, the world will look very, very different, right? And all this craziness that we are seeing right now of highly centralized compute, billions of dollars in chips, and cloud contracts, and $100 million salaries. That's why you're all here, right? Nuclear power plants and so on. What if that groupthink is actually wrong? And the company that's actually has created all this enthusiasm for the groupthink is also telling us a different signal, which is small models are the future of agentic AI, because the models will be under 1 billion parameters, run on edge devices, and will be very specialized, right? A math teacher model versus a legal expert model may not have any similarity in them at all, right? And so you already know this. This is a smart audience. How many people are like building their own agents, or keeping track of what's going on there, or starting a company, or involved in some kind of project, right? Like more than half of you here. So the second is the what, right? Like what does it mean to build an open agentic web, and what are the risks in developing that? So first of all, I mean, if you take the analogy of the World Wide Web with Tim Berners-Lee, right here at MIT, he was able to create World Wide Web Consortium, keep all these protocols open, and then other organizations emerged, like for DNS, for ICANN, and Mozilla, and so on. That did not happen for iOS and Android, or for like Facebook and Twitter, right? So we have these highly siloed organizations that have a lot of service dependencies. But what really frustrates us is this, opaque algorithms and unsafe governance. Right? That's what frustrates most of us. That we cannot innovate, and we don't have a say in how these platforms will emerge. That's not the problem with the open World Wide Web. So the open web would look something like what's on the left, which is we are consumers or businesses. There are open standards, and there's a cottage industry, of different kinds of agents and frameworks, and so on, and we can talk to any one of them, right? There are no gatekeepers. There's no walled gardens. But the stuff on the right, it looks more like an app store or Play Store, where to interact with other agents, I must go through the agent store, just like an app store, and even to talk to other consumers, I must use this particular platform. So everybody has to go through this gateway, and that's what creates walled gardens. That's what this creates disintermediation. As Sudheesh was saying, I mean, you might have in the future, like, hey ChatGPT, hey Alexa, hey Siri, get me an Uber. Uber shows up in 5 minutes. It might look very cool to you as a consumer, but Uber doesn't want that, because there's disintermediation. They cannot have relationship with their customers. They cannot upsell. They cannot show ads. They cannot improve their services based on their user data and so on. So they don't want that. And again, we don't want opaque algorithms and unknown governance there as well. And just to kind of make this point, Robert Leaf actually showed me about this, that the new toys coming up for kids this Christmas, where they can talk to the toy, like a soft toy, through ChatGPT and other API models. What could go wrong? Right? There's misinformation, there's addiction, there's inappropriate content, social isolation. We have no clue how this is going to play out. Right? And these things are just coming very, very fast at us. So we think something really dystopian could happen very quickly. We think over the next 6 months, there'll be very intense protocol wars. Some of them will claim to be open, but they're actually one-way protocols, right? Just like in PowerPoint, I can ingest a keynote, but cannot output a keynote. So it's a one-way open protocol, right? Soon there'll be companies will start to use their user base to create network effects and create walled gardens around them. So for example, OpenAI already has 800 million users. It's very easy for them to create a walled garden around that. Or Google, of course, has billions of users. Gmail, there's plenty of ecosystem for which they could just wall it off. And then very soon after that, about 6 months after that, you'll have oligopoly with maybe 2, maybe 3 players, in the whole world. And that are, even if they're using partially open protocols, there is dependencies, which means to create software, to disseminate software, to get ranked, you must use their platform. Ecosystem lock-in. There's not much a global south can do, other countries. And there's a massive innovation friction. You just can't create new things because you must use a very specific set of tools to launch your agents on particular platforms, right? So the equivalently in the World Wide Web would have been if there are only 2 websites to launch your business. One is called Squarespace and one is called Wix. And if you want to launch your company, you must go to one of these platforms. They have a website creation tool, optimization tools, debugging tools, and so on. And they will list the best businesses, best websites on their web store. And by the way, if you make any money, you have to give them 30%. Right? Imagine if that's how the World Wide Web would have looked like. Fortunately, we didn't get there, but we didn't land like that for everything else. And that oligopoly is what's going to lead to the very first slide I was talking about, the intelligence slavery, where we have not much agency left to be creative and contribute to society. And this is what could lead to despair and unrest. Not job losses, but because there's no soul left in the job you do. So that, and this is kind of game over. 18 months is game over for most of us. Or we could be on this green curve where we absolutely decide that all of us are going to use, all the developers, all the investors, all the startups, all the research, we're going to use open two-way protocols, right? And then new .orgs emerge, like projectnanda.org, equivalent of DNS, equivalent of ICANN, equivalent of Mozilla. The new .orgs emerge, and this consensus is built. And because of consensus, the long tail wins. There are thousands, millions, maybe billions of new agents and agent companies that are out there creating very funky things. It could be from your recipes to cat videos, whatever it is. As long as it's a long tail, they will demand to be open and vibrant. And those of you are like fan of Adam Smith and the Invisible Hand, this is how we could get to shared prosperity and keep the middle class going. Right? So we have like an 18 months window right now to see if we can keep the agentic web open. Again, I've talked to enough people. There's a paper that we're writing with about 20 different companies, some of the top companies in the nation. And we're writing this paper together to figure out how we can be on the green curve. Then finally, I'm going to talk about tech, but actually, I think Maria, you're going to show the demo, right? Yeah. Okay. So I'll keep this part short, and the question is, what can we do about it? And a lot of people are trying to build intercom. And how many people are familiar with MCP or A2A and so on? And we think of them as intercoms. It can connect two services to each other, right? But that's very different than building a telephone system, right? So, if I'll just give this talk in UAE. So I was saying that, at Four Seasons, if I were to call corporate sales, right now, there's a very nice hierarchy. And the country of UAE was given a country code +971. But after that, they have complete autonomy of how UAE should run their own telephone system, right? And Abu Dhabi is, 2. Four Seasons has a number, but then Four Seasons can keep all the extensions as a private registry, a private phone book, right? And we can use a similar analogy for what's going to happen. So in the agentic web, on the right side are the agent frameworks that you're all familiar with: LangChain, Crew AI, Agent Space, Agent Core, all those good things. Everybody understands that. The left part is more like the OSS stack that we have to build. And we think in this OSS stack, there are 4 choke points. And whoever controls these 4 choke points is going to control the agentic web. We could be on that red curve I showed you. Or we can all work together and make sure these choke points are actually controlled or managed by an open community, some kind of .org that's out there. And that's the mission of NANDA, of working on these 4 choke points to see if we can keep them open, right? So I'm just going to go through this very briefly, but look at our websites. We'll see some demos here. The first one is DNS. What's the directory for all the agents? Whoever controls the directory, like today, Google kind of controls the directory of, the content on the websites. LinkedIn kind of keeps the directory of everybody who's, trying to, improve their professional careers. So these places that control the directory of these things. So how can we keep the directory of AI agents open and vibrant? Second is agent passport, which is, it's not enough just to have agents, but every agent needs to have its own agent card, agent fax, agent passport, all similar terminologies. Which means that if tomorrow you wake up and you want to go to Brazil, most of your citizens need a visa to go to Brazil. You can't partially do that. You have to get a visa from Brazil. So even before you go to Brazil, they have to approve that you're willing to go there. Once you land in Brazil, they stamp it. So it's some kind of attestation that you actually did land here. Your passport is different than your business card. Somebody else has to credential it, saying that you're really John Smith, you're really 6 feet tall, this is your address, all those things, right? Those are the 3 main elements. Somebody else has credentialed it. Before you visit another agent, you have to take the permission. And when you have visited or interacted with another agent, there's a trace for it. But the 4th element is autonomy, which is that once the US government has given you a passport, you can do whatever you want. Nobody's controlling you what you want to do next. So you have autonomy. You can wake up tomorrow and decide to go to Brazil, or you go to Germany, or wherever you want, or stay home. And you need that autonomy as well. So with those 4 principles, autonomy, credentialing, visa, and trace, you can actually run a very efficient agent ecosystem, right? And again, whoever controls the agent passport controls the ecosystem. That's second. The third one is interop adapters. So, we're seeing this lot of message passing protocols like A2A, MCP, and so on. But beyond message passing, what you need is communication and orchestration of that. So hopefully there'll be 20, 50, 100 different types of agent frameworks and message passing protocols. But you need an ability for anybody to talk to anybody else. So you need some kind of an adapter, just like for EV, for charging your EV, you have an adapter. It doesn't matter which car you have, as long as you have the right adapter, you can talk to the system. That's that. And the 4th one is attestation, which is very similar to the passport concept I said, but imagine attestation of the kid's toy that's coming out for Christmas. So imagine if there's a system where before any company can release their toy, they must get attested saying it's actually safe for children. There's no misinformation, there's no addiction, and so on. But just like once you buy a car, it's not enough to get an approved car. You have to kind of do a checkup on a regular basis, right? So this toy may have to get a weekly attestation through online APIs that says, hey, when you bought the toy, it was safe, but the world has changed. And this chatbot's actually saying new things about some new news event or something that has happened, or over time, your kid is interacting and the context that has generated has some bugs in it and so on. So you need like a weekly attestation of this toy to make sure that it's still safe. And then finally, you need also some kind of an audit. Once the toy has been, is out there and there are 1,000, maybe millions of toys out there, you want some aggregate information to see if there's some edge cases where this is not behaving well. It might be working for one child, but in aggregate, is it working for everybody and safe for everybody? So you need sandboxes. You need like lead certification equivalent to that. And again, whoever controls that is controlling the choke point of what it means to be out there, right? The way it's solved today on the World Wide Web is actually very exciting. For all these 4, we have really good systems. For DNS, of course, we have ICANN. For agent passport, we have CAs, certifying authorities. For interop, we have built all kinds of, of course, any browser can talk to any website. but we also have Apache and we have Chromium and all these ecosystems that are built for adapters for each other. And of course, there's attestation, right, through verifiable credentials. So this works for World Wide Web, but nothing like this exists for apps. Nothing like this exists for social media. And hopefully it will exist for the agentic web. And that's the mission for NANDA. So I'm going to stop here and see if there are any questions. Yeah, go ahead. Yeah, no, very good question. So actually, again, there's a lot of experts from different companies, a lot of CXOs. And of course, it's an estimate, but it's based on some previous trends. So you look at things like, to get a dissemination of websites back in the 90s was very, very slow because only so many people have PCs, not enough fiber bundles and so on. If you think about the mobile phones, people have to buy a phone and so on. But you know the problem today, you already have the digital rails. That's why ChatGPT went from 0 to 100 million in just a month or two, because everything else already exists. So it's based on what rails already exist out there and what are the adoption rates we have seen for other things. But still an estimate. It's not a mathematical formula. Yeah. Does it seem too aggressive or too slow? 18 months to a complete lock, complete oligopoly. Right. Yeah. Now we're going to put 6 months, then we thought people will be so disappointed they'll give up. If you put 5 years, nobody will care about it. So 18 months is people feel like we can still do it. It also makes me feel a little bit happy that there's something I can do. This is our life, We are working on this nonstop for almost 10 years now, especially over the last 8-9 months or so. And so it feels like we can still do it. But every time OpenAI makes an announcement, you're like, oh, man. I think we have two less months left. Yeah. Yeah, go ahead.
I'm just wondering if you think there's a difference in terms of industry or types of application of agents that affects that timeline. So I could see, consumer applications changing much more quickly than health tech or something like that. So
I think it's mostly coming from a consumer agent's point of view. One underlying assumption here is that, yes, in the beginning, the investment will be in the enterprise agents, but they will dwarf very quickly with consumer agents. And even enterprises will, so there'll go be an equivalent of a ChatGPT moment where, before that, a lot of companies were using AI and Gen AI for quite some time. And when the ChatGPT moment happened, all the leaders said, hey, I can use this at home. Why can't I use it in my company? So, that's how the enterprises picked up. And the same thing is going to happen now. Like, I talked to many companies now, they're all fooling around with agents in their enterprise world, but nobody actually has a clue. Okay, they can say they have 1,000 agents, 10,000 agents, 100 million agents. It means nothing. It's all a mess. It's a major agent chaos that's going on right now. But it's good. They're trying it out. But I think the consumer world is going to happen, through very rapid iterations. Because in consumer world, you don't have as much friction. The reason why agents inside enterprises are moving very, very slow is that, first of all, the employees working on it are not reluctant, like, I'm going to lose my job. And the second is that these are all boulders. They're taking SaaS systems, administrative dashboards, and just making it slightly better by calling it an agent. And so it's very challenging to make that change in the enterprise world. But I think consumer world is like, clean slate, and you can move very, very fast. Yeah, so it's a consumer centric.
Ramesh, in order to really accelerate the adoption of NANDA, especially in many of these large ecosystems where you have many different constituents involved, you thought about essentially developing some sort of SDK that will allow for essentially the participants to quickly get the plugin and connect with each other in the ecosystem.
Yeah. So for all these 4 pieces, we have ridiculous software, reference implementation, companies building on top of it, startups raising millions of dollars. So all that is already happening. So we'll hear about that in a minute.
Excellent.
So you should all build, your own software based on this reference implementations. Great. And we have, dozens of companies working with us. and so on. We have this massive research groups. If you've seen my presentations, there are many big companies, pretty much everybody that matters in the space, is working with us. Like literally my team, like today and tomorrow is in 20 different places talking about this. Again, Akamai is like a major partner. Thank you, Hema. Thank you, everybody else. We already have a paper with Akamai on how Akamai is thinking about deploying things like NANDA going forward. Also Cisco, a lot of companies, some of them not listed here. You're all welcome to join the research teams that are working on this. Very soon you'll see the reference implementation. It's in 15 different places. Adapter has been built, people are already using it. We'll hear about the Sandbox. That's how we're going to launch these toys that we talked about, and much more. And again, there's a lot of agent chaos. So every bullet in this is a billion-dollar company. You should go and start a company in each of those areas because it's a massive mess. Nobody knows how to solve these problems correctly inside enterprises. So big opportunities there in each of these areas. Hema was just talking to me about security on the way here. Like, what about security? I was like, yeah, that's like $1 trillion opportunity right there. Because as you know, anybody who claims that technology is going to make your life easier is only partly true because it's only going to create more mess, right? Look at our emails, look at our phones. Yes, they make our life easier, but makes it even more busy, right? And agents, first of all, the agents that are created with vibe coding, nobody knows what code there is. My guess is that 10 years from now, people are going to start calling me saying, hey, you know how to really code, right? Didn't you actually used to code in C and Java and everything else? Like, can you tell us what is going on here? Because the people who created it don't really know what was built here. So there's going to be a lot of technical debt that's being accumulated, and it's going to explode at the vibe coding rate of the technical debt of building this agent. So plenty of chaos, plenty of jobs in trying to tame the agent chaos. So to your answer to your question, yeah, there's a lot going on in the NANDA framework, and we work with everybody as well. So, yeah. All right, I think I'm going to move on. And who's next? Sorry? Hema. Hema, you're next. So, Hema, first of all, thank you for hosting us here at a beautiful Akamai headquarters. And as you know, Akamai is the leader, also an MIT spinoff, just like NANDA. But go ahead.
Thank you all for joining us. Thanks, Ramesh, for that wonderful talk and the opportunity to host this event over here. So as you all know, Akamai started 2 decades ago, which is across the street. Professor Tom Layton, the founder, was a professor at MIT then, and then, so I feel extremely exhilarated because I think we're in that kind of, I feel the same moment that probably Tom would have felt 2 decades ago, right? So we kind of this cusp of kind of the latest and the greatest. So the problem Tom was trying to solve was the dub, or the dubbed as the worldwide wade, right? So I think we're kind of at that moment here where we can actually solve those type of kind of seminal problems in kind of the agent communications or the protocols. So we're not saying, I'm not going to say that, hey, the MCP of the today are going to be the MCP of the tomorrow, or like NANDA or A2A. There could be something else in the future. It could be, an alpha beta gamma protocol, or like an Ada Lovelace protocol, or a Marie Curie protocol, right? But that's not what matters, right? What we are trying to do here is kind of, we are being the trailblazer. I'm really honored that to work with, Akamai is really happy to work with Professor Raskar and his amazing team, brilliant team of MIT students and fellows from Radius as well. So you're going to see, I'm not going to talk for too long, so I'm going to let you all see what we have done. Professor Raskar said that there's a lot of demos and whatnot. You can see Maria present some of the work that the researchers have deployed in Linode. So if you don't know what Linode is a competitor for AWS. So we have our own. So Akamai does more than just the internet. You can see our security leaders over here. Say hello there. So some of the fundamental problems we need to solve is, hey, one is agent-to-agent communication protocols. How do you have databases talking to each other? How do you solve, how do you kind of create new ways of communication, right? Like, so we all know that how the world is going to change. What we are doing today is going to be drastically different from the way it's going to be in the future. I published a recent blog on LinkedIn on, how we are going to, how we, as organizations, we have to change. It's a non-technical kind of leadership write-up. So I'm not going to go into the details, but take a look at it. But essentially, AI is not a hype anymore. And we've got to actually figure out not only how as humans we work, but essentially kind of rethink the way how the databases, how the applications, how the whole architecture and the systems need to talk to each other. And so what needs to happen is kind of, while these POCs and proof of concepts, and it's exhilarating. I wake up in the morning and I'm sure all of you are thinking about this. How can I have a little piece of history here, right? But then there's very strong challenges, bigger problems to solve is in, hey, how is all this going to scale? How can we put the security? So it's actually, giving a ChatGPT doll to a 3-year-old is scary for me, right? I mean, would I want to do that? Absolutely not. But that's kind of how crazy things are. So I won't go on talking about this. It's exciting as well as scary at the same time. But so I just want you to kind of hold on to your seats, and you could see the demo from the researchers, both at MIT, and you say hello to my Northeastern students who are doing the capstone work, and you can see some of their work as well. So thank you.
My name is Sudheesh. I'm one of the co-founders and CEO of TinyFish. We are a Series A company, a little over a year old. We just launched our product this morning at MTech conference at MIT. And Lee Howe, who's my colleague there, he said, somebody's asking us to come and talk again. I'm like, okay, sign me up. Like when you're a startup, you're always trying to see any opportunity. When there are 200 people competing for pizza, I thought, why not, right? I'll tell you a little bit about myself and the company. So I was CEO of a company called ThoughtSpot for the last 6 years. Before that, president of a company called Nutanix. I've done startups. We are out of Bay Area. TinyFish is agentic web, and I usually don't see this at all. So this is really nice to see becoming a thing. What I'm planning to do today is not just show you a bunch of slides here, but actually live demo. So, I mean, with a topic like agentic web, I'm assuming that it is not a surprise to you when I say that when you are Googling something, 90% of the web is not touched. Google can only reach 10% of the web. In fact, 10, I'm being very generous. It's anywhere from 5 to 7% of what we call the surface web. Almost 90%, more than 90% of the web is inaccessible to search. And it is actually inaccessible to search, which means that it's only going to get worse as we start moving to LLMs for answers, which we all do. Now, if that's the world that we are going to operate in, how do we move away from something like that to something different? Let me just start by demonstrating what I mean by that. I'm going to start with ChatGPT. Actually, this is Atlas, their agentic browser from OpenAI. And I want to be very clear, so I'm actually going to use the same exact prompt on both. I want to ship a small 5-pound box from SF to Boston. How much would that cost? So this is not something ideally you should be able to just scrape from the internet, because this requires running a workflow. But these agentic browsers are good enough that they will figure out a way to get that going. While it is doing, I'm also going to show you the same thing on our product, which we just launched. Actually, we haven't launched yet. We are about to launch, I would say, in the sense that it is still in limited availability. Because last night, 4 o'clock, we were still coding. I want to ship a small 5-pound box from SF to Boston. How much would that cost? All right, so 2 things going on here. Here, it is trying to do a bunch of things. And usually, this is essentially what is going to happen in the end. It is going to come back with this. And here, what you will see is that it is going to kick off multiple instances into what we think is, what the system thinks is the proper opportunity for it to execute on. So here, you can see that as it goes through each one of these, it's showing me a link, and within that link, it is showing me a range of where it should be ending up. And the reason why this is happening is because to execute this specific workflow, it needs to have access to a few things. First, it needs to execute the workflow. Where are you going from? What is it? So in this case, it found USPS. This is UPS. And this is starting another browser. I'll explain what's happening. This is DHL. And in case of USPS, it's actually finished it in like little over 35 seconds or so. It finished that, and it uploaded the information about what it found from that. Now, if I were to move this to behind here, this is another one, that one. This is UPS, and UPS basically requires, you can see here, it's got CAPTCHA going on. There is pop-ups and agentic web. Things like CAPTCHA, calendar, these are all extremely difficult for it to navigate, because most of the agentic browsers, what they do is they take screenshots and then feed everything to LLMs to infer as part of this process. And it comes back with pixel that needs to click. And pixel-based clicking is really difficult when it comes to calendar navigation. So here, I'll show you what we do differently. And UPS still requires the entire horoscope before it shows the price, so it's going to go through that. Everything else finished. So you can see here, there is USPS, there's FedEx, there is US, all of this data is out here. And what happened underneath it is that the system used the query, executed that using, as you can see, it's all MCP underneath it, but it's using NL Web from Microsoft. It's learning, it is executing the process, and the data is coming back in form of, essentially in the form of JSON in this specific case, or CSV. So the whole process finished. What it did is it actually went to all of these websites, entered the origin information, filled up the form. FedEx requires you to pick a name and address, so it filled up all. It's fun to watch these agents pulling in names like John Smith, Jane Smith, just like humans do. Came back and finished it. So let me just come back here and explain what happened and why is this significant. Because when I say there are 90% of the web under the water, so to speak, there are 5 types of data that is inaccessible. The first one is obviously API-driven access. So think of like your airline information. If you want to find out the price for your airplane, the ticket price is not something you can immediately get unless you go through a platform like Expedia or Google Hotel or Google Flights, where they have API access. So that's one. That kind of data is not something that you can search. Second is workflows. Your doctor's information, what is the next availability? I don't know. You tell me, when do you want to go, what kind of doctor, right? There's a workflow that you have to go through. And third is contextual. Your browser on Amazon.com is going to look very different from mine because it knows my story, my preferences. The same website is going to be looking differently. So that is not something you can, search. Logins. Pretty much everything is going behind the login screen. In fact, with LLMs going indiscriminately scraping everything, more and more content is going to go behind logins. All social media is behind login. Reddit, Twitter, TikTok, all of those things are. Almost all media, New York Times, everything is going behind paywalls. And then not to mention more and more private content as well, including like Substack, and everything is going behind logins, because why would you spend a couple of years and write something, research something, and put it out there? And within a matter of seconds, LLMs will scrape that. And the difference is when Google used to scrape without answer engine for every 7 queries, it used to send 1. Now with answer, it is 15 to 1. But with LLM, some of them like Claude is 36,000 to 1, which means 36,000 queries are answered before you get one to you. Why would I spend time researching and putting content out there? So that's the fourth. And the last one is what I love, which is long tail. Imagine if you search for, you go to Amazon and search for something. You want to buy a case, iPhone case. Just imagine yourself. You searched it, clicked it, and what happened? Is it delight? No. The first 15 are like cleverly placed ads and sponsored results and all of that. And then some of those reviews, that are actually bombed by somebody, or AI is writing it, AI is summarizing it, AI is reading it. And then there are 15 pages. You're not going to go through those 15 pages. Chances are there might be one on the 14th page that you will never get to. That may have been the right solution for you, but you're not going to find that. That is the long tail of the internet. This is an 8-room hotel in Japan who don't have the API to constantly update Google Hotel and Expedia, but they have an amazing service that you will never find. This is a small coffee shop or a coffee plantation that is organically growing in Nicaragua that you will never find because Google or ChatGPT may never feel like it needs to be put it out there and they're not going to spend the money. This is long tail. This is what we call TinyFish. That's why our company is called TinyFish. We think the web has to evolve. Today, when you think of the web, it all started in the 24 years ago when Google started. Web was static. And when it was static, it made perfect sense to index it and say, we are going to organize the world's information and be the gatekeeper. And it was extremely useful. And Google is an amazing company. They are as noble a company can be. The problem is web is no longer static. 90% of the web is dynamic, like I said. Everything is constantly evolving, changing, redrawing itself. And when everything is redrawn, you can't be searching. Searching by definition means you're lost. In a dynamic world, you're always going to be lost. And then we moved to the next time, which was, okay, I don't have the time or thirst to go through all those 10 pages or even one page of 10 links. I just want the answer, just spoon feed me. And we are getting used to that with models, answer engines telling you exactly what you think is the right answer. The problem is, if only 5 to 10% of the data is indexed and searched, and under that, you are now getting one answer, the quality of information that you are getting is going to get worse, not better, which means 90% need to be operated. We think that's the opportunity that will be tackled in the future. If you really think about agentic web, it has to operate 100% of the internet. And here is what we have done. First, we don't think of browser as an agent that needs to be operated on behalf of you. Today, when you think of agentic browsers, it is like, give me your computer, your browser, your credentials. Let me operate it for you. Now, that is good, but that's not the real problem here. The real problem is that there are a long tail of internet. There are forms to fill. There are things to do where I need my agents to work on behalf of me. Imagine you set a goal, and that goal is completely handled by a suite of agents. So our architecture, the one that we have taken, is this. We have our own browser agent. We can also use browser agents from like Operator and others, from OpenAI and others. But the difference is, ours is what we call multimodal. So think of it like, if you go to a doctor, the doctor looks at you and says, you look pale. That's actually pretty good. But that doesn't mean that you don't need X-ray or MRI, no matter how experienced a doctor is. One of the problems with the current models of browser agents is they're all done with nothing but visual reasoning. As things are moving, it is like I said, it takes screenshots and feed it to LLMs, and it comes back with an answer. Say, go click on this pixel. The challenge here is that, A, that is extremely slow, as you have seen probably. It's reasoning constantly for a long time. B, these are non-deterministic workflows sometimes. And when non-deterministic workflows are involved, LLMs are not the best model, because if you want to run this 100,000 times, we have a customer where we are running 800,000 times this. You want deterministic execution. And LLMs, just like us, tomorrow if you invite me for this presentation, my presentation will not be exactly this. That's how we are. Models are like that. But in this new world, you need deterministic execution. So what we have done is we use LLMs to understand the lay of the land. And once we do that, we take that, we decompose that goal into tasks and skills. So imagine, let's say you want to buy a case from Best Buy, that's the goal. We might decompose it all the way to an atomic task as clicking on a zip code or entering your coupon code, whatever it may be. That is the atomic level that we break it down to, and then we train a nano agent to do just that. However, we also orchestrate it in a way that we can decompose it back to the goal. Second part, once we know what that atomic part is, we codify that, and then we use a self-improving agent codification framework. So Google released something called OpenEvolve. They call it, Alpha Evolve. So we have an open version of that. So this is like coding without human involved. Because remember, one website may have maybe 50 or 60 different agents working on them. So you have self-improving code that is executing on CPU. So that's the second. That's where we get deterministic execution. Once we do that, now you need to spin it off maybe 100,000. Remember, we are not selling to consumers. We are going to large enterprise customers. So if you are trying to book a hotel, we are not trying to sell to you. But Expedia would love to have this because now they can simulate 100,000 parallel sessions from 50 states and see how is Marriott properties represented on my platform versus Booking.com. That's a use case that we could, which means now you have 100,000 sessions to run, which means 100,000 browsers running somewhere on cloud. But these need to be extremely fast in hydrating. They need to have session persistency, cookies, some level of fingerprinting. Maybe it needs to bot detect. It needs to have proxies to set where it is coming from. All of that needs to be there. That's the third part. And the last is, by doing this, we are flattening the website. Because one of the data that is not available is, like I said, is login-based and workflow-based. These two kinds of data are now available to us. Because if you go to TinyFish.ai, you will see we highlighted a story of that 8-room hotel. Our client is Google Hotel. So Google is our client. And they have thousands and thousands. There are tens of thousands of hotels in the world where they don't have the API to put the availability and pricing on their platform, so they don't show up. They will show the hotel, but if you ask, do they have availability? It will say, call the property, and no one calls nowadays. Nobody wants to talk to anyone, right? So people just skip over that and go to the next one. What we do is that our agents log into these hotel websites, mom and pop, small hotels, multiple times a day, and create all combinations. Queen room, king room, check-in, check-out dates, all varied combinations. And then extract the price and availability and automatically upload. All of those websites are now as if they are front-ended with MCP, because now you can have a conversation with them. Who are you? What do you do? Do you have availability? How much does it cost? Can you do it for me? All of those availability, because you can navigate like human. But to my point early on, it's not just visual navigation. We visually navigate, visually actuate. We look for APIs underneath it. We can also look for other clickable elements. We have a complete view as if MRI, X-ray, and visual information of it, which means that we are very efficient in how we execute. That's why within the few months of launching now, we have over 1 billion plus data points on hotel information in this specific country, which is Japan. That is a flattened information that's not available on anywhere in the internet, because these are all temporal pages that we can, these are all ephemeral pages in which we are capturing information from. That is used to train our model, because that's unique data. And that data is used to improve every time these agents are running. This is the model that we have built. And this model enables use cases for enterprises. Retailers who want to do competitive pricing, they want to do a markdown, they want to do promo, they want to complete catalog and compare that with Lolos. Want to see if the Home Depot has the same product. If they do, what's that cataloging like? Am I missing some key pieces? Travelers, travel and hospitality companies. This is simple examples like I may have a hotel listed on my website, but I failed to capture that the hotel has, let's say, Wi-Fi. Now you as a consumer comes in and filter, remove any hotel that doesn't have Wi-Fi. And then I lose that business even though the property has Wi-Fi. These kind of small things are huge impact in retail. These are not something that is friendly for humans to do. Our agents are able to do these sort of things really well. So use cases like that. Some cases, like healthcare, most of the healthcare pharmaceutical companies, when they do clinical research, they want a lot of people to, like in the pool. Most of them are running with very, very low amount of participation, like 16 to 17%, as low as that. The people are there, it's just that they're not able to reach them. Imagine using internet to research, engage, reach out, and extract. All of that, human-like reasoning at a superhuman scale. That is the possibility if you extract or if you abstract browsers away from humans. But that's not an agentic browser opportunity. That's what we call operating the web using agents. So very early stage company, just a little over a year old. We've raised around $47 million. We have around 25 to 30 people in the company. But that's all it takes nowadays to build companies, because the efficiency with which you can build these companies are changing. This is a fast moving space. I think you guys picked a really good topic to start with. The most important thing to know is that these are deterministic execution. When it is executing something, it is going to do the same thing because we decoupled inference from CPU. We take the goal and decompose them. And the speed with which we are able to orchestrate them. If a website changed, let's say a radio button became a calendar, a small nano agent might move away, go back to LLMs to learn and come back. All these possibilities are opening up. And I personally believe that the way we have been working on this web is not going to continue. We will not go from SEO to GEO. That is not the future. The future will have to be something where the 100% of the web should be operable for all of us. And we think this sort of architecture could potentially deliver high value. And so far, in little over a couple of months, customers like Google, DoorDash, ClassPass, and a bunch of others who haven't really given us permission to speak publicly, all have deployed this in production. We have little over 36 million of these agents in maybe less than 20 customers, and it's a fast growing. We launched the company. The company was launched a couple of months ago, and this platform is in limited availability starting today. So thank you. Yes.
Thank you for presentation. The question I have is, it's fantastic, but how you're going to protect your user with zero clicks, markdowns, and rogue agents?
So look, I think security, governance, policy, auditability, accuracy of data, all of those things are extremely important. So what we have done is that we have decided to start with use cases where we are only doing internet data. And that was an important thing, because when it is internet-only data, the prompt injection, authentication, authorization, those things go away because we are not dealing with any of the internal data. We will get to internal data at some point in time, but today our focus is only on internet data. I know, but what I'm saying is, in our case, zero-click is useful for us because we are pre-processing and post-processing the data in this specific case. So our approach is that we start with frontier models leading the way when it comes to security and governance, but internally our focus is to really extract the data as much as possible and process them in a way that actually makes sense for the businesses.
Can I ask you a quick question? Thank you. First of all, exciting. The whole industry of RPA, robotic process automation, it's like $30 billion, I think. You could potentially kill that by.
If people were to ask where is the money coming from for this project, there are three areas. One is definitely RPA. RPA is not robust because as the websites are changing, the scripts are changing, and this is fully, adaptable. Second is there are a lot of human capital involved. And the third is there are scraping companies out there scraping and then providing data. I don't believe that we want to go after scraping as much as we want to go for intelligent automation. So intelligent automation will squarely fit into RPA. So I do think that will be. But RPA companies are also evolving. They're also using agentic technology to adapt there. Yep.
Thank you for your presentation. I just read this post from Perplexity. They say Amazon just blocked their agents from how do you handle such privacy?
Yeah, so the question is about Amazon blocking. So let's figure out why though. So the primary reason most companies are, most of these Amazons and Google and others, there's a lot of Amazon's case, close to 30% of their, I don't know exactly 30 or 33% or something like that is coming from ads placement. And if you walked away from the screen and your agent is operating, it doesn't care about ads. So ads are inefficient for them. So there is going to be some sort of, it has to come to terms with, there are two forces coming together. First one is, you can't stand in the way of user experience. That's number one. Number two, on the, like if you think of Cloudflare, Cloudflare started this whole revolution a couple of months ago, July or something, saying that they're going to stand in the way of LLMs having access, automated access to their website. You got to think why they are doing it. They're doing it because they want to be the ones gatekeeping the content so that they can make money from content creators. My view is that user experience and convenience will win over. The monetization model that Amazon will have to evolve. The same thing applies to Uber, for example. Whenever you pick up when you are requesting a car, it's showing a bunch of ads. If agentic process are ordering your car, all those are wasted. Google has the same problem. So between Google and OpenAI, there will be a sort of equilibrium that needs to be figured out. But from there also, Perplexity is obviously writing blogs, but Perplexity, Amazon, the relationship is somewhat asymmetrical. But Google and OpenAI, as they figure things out, I think all of them will actually help the way agentic automation. I do not think you can put the genie back in the bottle with respect to bots out there. Already it is around 50% of the internet traffic is bots. With agentic, it is expected to get to close to 74% right now. So I don't think there is anything stopping this. The monetization model will have to change. Last question? Yeah. And the question is, will ads be? So I think before that, authentication and payment needs to be streamed out. So once those are streamlined, there could be potentially, so OpenAI is already talking about that. On their application platform, they will be injecting ads, which will be seen by curated agents as well as humans. So you might leave the agents and come back and the agent is going to sell you things. So everything is going to be monetized. Ultimately, every company will end up becoming an ad company. Okay. Thank you. I just want to say thank you to Nanda and Umesh and the rest of the team.
So wonderful to see you here.
Next up, we'd like to invite Scott to the front. Scott comes in from GoDaddy.
Okay, thank you. And thank you for letting me be here. This is lovely. We don't have anything like this anymore at GoDaddy. Got rid of most of our real estate. But yeah, it's good to be here. Something I want to mention at GoDaddy is we actually have websites. We have about 6 million of them hosted there. I run domains engineering, DNS, that sort of thing, and also Edge for GoDaddy. In terms of domains, it's a bigger business for us. It's 85 million domains under management. These are paid domains. DNS, I looked at a couple, right when we were getting started, we were doing about 1 million queries a second, which is not a ton for DNS, but it's a lot when you compare it where we are in the agentic world today. So why do I mention that? Because I think we do have an existential crisis. I don't know if we have one that's the months that Ramesh told us about, but I think we have a problem here with walled gardens. And we're concerned about that at GoDaddy. We know another number of other companies are concerned. Even some of the hyperscalers, even some of the LLM providers are worried about this. Even though they might be the ones rushing to do it, they're also worried about it. We found, we had a problem back in summer, and the problem was this: we started to create agents for our services. And then we were like, okay, now that we created these agents, and the agents for us was really just anything with an LLM behind it. It wasn't MCP or ATA, it was typically a RESTful API, maybe even a UI. But we thought, oh, how do we register our own? And so I was asked to look into that because I run registries. And then we started to look at customers, and we said, what if we had, what if we turn this on for managed WordPress? What if we started with a million agents? Are we able to handle it? How will we register them? How will we find them? And we saw the paper that had been proposed at ITF and then later at OWASP by Vineet, who I saw on the board there a little bit ago. And that started to make a lot of sense. I don't know if y'all have looked at Vineet's paper, and let me see if I have something here. I gave a document. I don't do slide decks. let me go on. Bing, 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 bing. Yeah, okay, so inside of the needs paper, he describes a way that we can armor or a way that we can provide identity for agents that go out there. And I know we looked at it, other people looked at it, and the immediate answer was, oh my gosh, this is a Web3 model. In fact, he envisions that in the paper, right? We have an agent out there, we have to know everything about it, we have to know every transaction. Boy, it'd be great to put that somewhere in an immutable log, we'd know just what's going on. The issue is, we do believe in the problem Ramesh mentioned, that we have an existential crisis right now on the open internet. And we couldn't wait 7 years, or however long it's going to take, or 15 years for this infrastructure to get built, to get trusted, to pass audits, all the things we have to do now when we're doing high value transactions, when we get sued, when we get audited. So we're like, what can we do? Well, I have a lot of Web 2 responsibility, and I thought we could turn that on now. The one thing that's interesting about Web 2 is there's not a monopoly at any layer. So what did we do? We chose, gosh, if there's an agent, we could associate it with a domain name. Now, will domain names blow up? No, because it would be a fourth level domain name, right? Domain names are an ontology. You start with .AI, and then you have a second level, third level, fourth level. You could have 17 levels, right? There's a limit in the number of labels. There's a limit on the number of bytes, but that is a ultimately scalable system. We look at DNS. I don't know if you know this with DNS, but DNS is not designed at scale for DNS queries. DNS queries do not keep the lights on. I remember over a decade ago, we had, what were the big, there were Maye attacks, right, that were hitting? And what we'd see in 30 seconds is the query rate would go up 100x or more, 150x, 200x. So back then, I think the company I was with was handling 2 million queries per second. We saw 400 million queries per second, 45 seconds later. DNS is built for DDoS attacks. That's how Cloudflare's architected their DNS. Everything's about attack mitigation. DNS is just queries. Why do I mention that? Because if we stay ahead of the attacks, then I'm not worried about the queries for 2 or 3 orders of magnitude. After that, I am worried about it. After that, maybe we say Web 2's run its limit. But for now, I think we can, with some Web 2 solutions, armor agents in such a way that we're good for a couple of years, that we have time to do some of the work that you all are envisioning, particularly with Project NANDA. Now I'm starting to wish I had prepared slides. Let me jump right to the end. All you're seeing here is different examples. I was going to actually have a demo. Okay, I'm going to show this slide, one more, and then I'll be done. What are we looking at here? So at the very bottom, we have an agent that's working out on the open internet. And that agent, imagine it's an MCP agent. And in our case, we do a couple things. It's really, really simple. Anything you do at scale, at least that I've done at scale in my career, it's always been simple. It's kind of like routing, right? Routing, you can be really simple. You start doing all sorts of filtering on it. It starts to break it high when you get lots of traffic through it. So in this case, when we're talking about an agent in an agent registration system, we're saying we're only going to do a couple things with it. You're going to give us an agent, like your MCP agent or A2A agent, or even a RESTful, endpoint. And we're going to say, number one, can we associate it with, for now, a fully qualified domain name? So my agent might be agent99.scott.example.com. Okay. And then I have another agent, and it might be agent 100 or whatever, give it a better name than that. But it's a fully qualified domain name. Why is that? Because when I talk to you and I'm about to pay you money and you say your name is Ramesh, I don't want to be about to hand you money for some transaction and have another Ramesh pop up behind and say, oh, but I'm really Ramesh. When I talk to somebody, I need to have a clear activity. In Web 2 space right now, there's a way to do it. It's called domain names with DNS. The second thing on that is identity, and that was your second layer. So I just talked about the bottom layer. Next layer above that is the identity. We say that every MCP agent that comes in that we're going to register, we're going to ask that agent creator or agent hosting platform to give us 2 CSRs. So we're using certificates. The first one is your typical TLS or SSL certificate, right? Issued through a public CA. It says, I am who I am, I own this domain name. The second one is an identity cert, private issued, which comes with its problems, but it allows us to do all sorts of things. And that is where we establish trust with this model. So again, a Web 2 model, but every agent that's coming through has a name, has a server cert, has an identity cert. The next thing we do with that is we create DNS records. DNS records fundamentally point to two locations. One of them is the agent card, or a set of agent card informations, JSON blobs, and the other is to a transaction log we keep, which looks a lot like a blockchain journal, though it actually isn't right now in this Web 2 implementation. We used a Merkle tree. But either way, it's an unalterable log. So we rolled this out. We announced it a month ago. We went production alpha on Halloween. We'll be on production beta where we have people working into the system in December. Right now, we're eating our own dog food. Last thing I want to show, this is our API endpoints. They do exist. It is live. It is a production system. It does handle traffic. Last thing, real quickly, because NANDA's up here, up to the top, and it might just represent my misunderstanding. This is my generated document, right? Generated the XML and pulled it into dry. But the point I'm trying to make is I see a foundational identity. I don't show 4 layers, but I see 3. Foundational identity looks a lot like this agent name service. How many of these registration authorities would there be? Well, there might be 200, there might be 1,000, whatever. It won't be a monopoly. You probably will have Wix being one. You probably will have Cloudflare. GoDaddy's going to do it. If I were running a CA, GoDaddy is a root CA, so of course we're interested in that. If I were running a root CA and there's about 200 of them, I would do this business. So that's that foundational REL layer. It produces armored agents. Then above that, we have a little utility that we run that checks every day, but we're starting to rely on the community. And you can see where I call out, say, A2SPA. On top of that, we need some sort of Web3 approach, some sort of Oracle approach out there where you have people saying, I know what that agent's doing, and I'm reporting it here, 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 and here, because Web 2 can't keep up. That's what I've got. Yeah, thank you.
So I'm glad you had the 3-layer diagram, and people often get confused about, what do we mean by DNS for agents? And there are 2 ways to think about it. One is you could have a very centralized model like today's DNS. I mean, it's hierarchical, but still somewhat centralized, which is you somehow have a list of all the agents. In today's DNS, if I were to change yahoo.com, somebody from Yahoo has to go and change the IP address, and that cascades over time. So if you have trillions of agents, then you have this massive problem where the propagation is going to take a lot of time. There are going to be a lot of hits to this registry, the DNS registry, and it could become a little bit unwieldy. So that's kind of one way to think about it. The other way to think about this is the way you mentioned, which is let agents hang off of existing websites, right? So they will be, if you're already on yahoo.com, you can have agent1.yahoo.com, agent2.yahoo.com, and things like that. The second one is interesting because now you change the listing problem into a discovery problem, because now nobody knows where these agents are, and some other entity has to go and make a list of all the agents that are out there, right? And once they have created this massive list, then you have re-centralization. Now they're going to decide out of this trillion agents, which one should surface, when I search for something, or which one should be allowed to be out there, and so on. So this is a challenge, right? Like if you try to do something like DNS for AI agents, like a new list, you get good centralization, but a very ineffective, very slow updates and CRUD effectively. But if you do decentralized, then you have a new Google will emerge, which has to provide after some kind of re-centralization. So what's your take on that?
Well, going back to the first point, in terms of DNS scalability, today there is one root. The root has 1,500 zones in it, or 1,500 domain names in it, I'm sorry, and like .com everybody uses, right? But there are 1,500, these top level domains we call it. Those 1,500 top level domains can be run by anybody, but it is a limited set. The registries run these. And then beyond that, there's second level domains. .com alone has over 150 million domains in it. There's about to be a new round of top level domains next year. So this is a central business. But then again, if you think about it, research universities are a central business in the US. We have less than 200 R1 research universities. So I'm not, when I look at DNS, though, I think, here, I'll give you an anecdote. Years ago, we would measure, back when I was a VeriSign, we'd measure what was going on .com, the root, whatever, in terms of individual recursive resolvers hitting us. And we'd see immediately the top 10 gives us 90% of the traffic, like Google, whatever. So you'd see, oh, all this traffic immediately hitting from some of them. We'd stop counting within 2 days because we'd be at 10 million recursive resolver. This is a very, very distributed world. On the second point, discovery, if you look in the ANS draft, discovery was part of the agent name service. That to me did not scale, so I got rid of it. What happens here, instead of discovering, and that goes back to the first talk, instead of crawling, whatever, we set up a pub sub feed. And this RA is an open source RA, right, or open standard RA. We're contributing back. We expect we'll have competition in it. We expect there'll be hundreds or thousands of these. They just have to follow the standard. The standard is when you register an agent, when you version bump the agent, every time you version bump it, you change the identity cert, you write that to the Merkle log, whatever. But you don't have to crawl the internet. You don't have to say, why did I only discover this or that? What you see is a constant stream of either new agents coming in the system or agents being bumped, agents being changed, their information being changed about them. Because that, I think the search side of it scales. Now, I will say this. If the agent itself starts changing really, really quickly out there, in terms of its actual use, and it's not updating its meta information, then that's where we have to rely on something like NANDA.
So I hope everybody here appreciates how complicated, it's seemingly easy problem, but even with a moderate scale, it becomes very complicated, right? And I mean, one thought experiment, based on what Scott said, is imagine if you, had built the World Wide Web the right way, which is that, the moment somebody launches, a website or a page, they just go and dump either the raw page or its vector DB on some central database, effectively. I'm simplifying it, of course. And even if you have about 150 million .com websites, overall there are about 330 million websites right now.
At the second level, yeah. The third level, more.
So the top level domains are about 1,500,
Mm-hmm.
and there are about about 330 million websites. All that information is not that big. It could be like a few terabytes at best, right? If you put it all together. And you could have eliminated need for something like a Google search, not because we don't like Google search, but because you want to make it extremely democratic. We could have solved that problem, right? As a thought experiment. Now, can we do something similar in agent space? Because the challenge in agent space is that you cannot use some kind of a page scraping, because if I encounter an agent, I can't say, tell me everything you know. And you index, you kind of store it in a central location. The only thing you can do is say, oh, you exist there. Tell me what you can talk about. And the agent might give you like a 1-paragraph description, but not everything that the agent knows, like a website would tell you. And based on that, a paragraph of information, which in agent card world is called capabilities and skills, you have to figure out what to do with this agent, right? So I just want to make sure that people realize that it's a very different problem for a DNS of websites and pages to a DNS of agents, where the agents will be many, many more, but each agent doesn't have much to say to be stored in a central database.
Yeah, I kind of wish it had been done like that. We actually, in every big web provider, if you really look at what they're doing, their data is all sitting in a database. Same thing with storefronts. You look at Etsy, for instance. Right. I think it's all data in the back end, right? It looks like individual storefronts, but it's also, and I believe that the feeds now to the LLMs, such as the Etsy OpenAI thing that was announced recently, is just really a big fat database feed going from Etsy over to OpenAI. That's changing the sort of the way we do work.
Which is what, Sudheer's company, Sushil, right? Sudheer's company is doing it as well. They're trying to create a direct connection between the databases to the websites. Although in the beginning, they're doing it based on scraping. And even Akamai's business model, right? It's kind of unique because you don't have theoretically, you cannot copy over DNS. So you cannot just take the 330 million websites and copy over their information. DNS doesn't allow that. So most companies over time learn what that is, right? They effectively accumulate every time you talk yahoo.com and the connection goes through, Akamai says, oh, that's where yahoo.com is. And all the Cloudflare and all the private DNS, that's how they're accumulating that information. And I feel the agentic DNS is going to be something similar, where over time you accumulate everything that you know about everything that's out there about agents. So I just want to make sure people appreciate that this is a very different problem from a traditional DNS as well. But let's see if there are a couple of questions for Scott. It's stunned everybody.
It's pretty low level is the thing. Yeah. I'm just saying adopt it for now. If you could, it's not gonna, I think it's not gonna be a big pricey thing because the money isn't there. The money is on, like you might have said, it's all these adjacencies, right? And that's all the patent.
Service dependencies. So I think to give a scale, I think ICANN is it 200 million roughly in revenue? So there's ICANN, which gives you the domain name. Then on top of that is VeriSign. On top of that is companies like GoDaddy, right? And I think VeriSign is like $2 billion roughly.
That's the domains business in VeriSign.
Okay.
Yeah.
But if
no, that's about right. Yeah, I'm sorry. I thought you were talking GoDaddy for a second. Trouble having worked.
You guys about 5 billion, is that right?
Just about there.
Yeah. So if I remember the numbers correctly, it's about $200 million is what ICANN makes, the nonprofit. VeriSign makes about 2 billion, and GoDaddy makes about 5 billion.
But yeah, about 2 billion of that's on the domain side. The rest is all that website, certificate authority, all that.
Yeah. I mean, all I'm saying is that somebody should go start these companies that are running on top of this. Just like this, for one GoDaddy, there are many others, officially different sectors and so on. But it's still not a tax on the system because it's just a few $1 billion. They're not like GoDaddy or maybe VeriSign is, but at this, companies like this are not becoming choke points in the system. They are making billions of dollars in revenue and enabling the whole ecosystem, right? They're not extracting hundreds of billions of dollars of value away by becoming some kind of a parasitical organization. So I think kind of new set of companies, or I'm sure you guys will do something very clever as well in this space. For those of you entrepreneurs, researchers, founders, that these new opportunities are emerging in each of these sectors.
Yeah, thank you. Well, I really appreciate the work you all are doing. You have a much
thank you, Scott.
broader view.
Thank you for joining us. Who's next?
And next up, we'd like to welcome Maria.
Hi, everyone. Yeah, so I'm going to keep it short, but my name is Maria. I'm the researcher with Project NANDA. So specifically today, I'm going to talk about MCP. I'm sure most of you, actually, how many of you have heard of MCP? I mean, read the event. Okay, great. How many of you build MCP servers before? All right, half of you. How many of you used MCP servers with like ChatGPT? Okay, this is great. So it's going to be a very easy presentation. So again, MCP was open source, a year ago on this day by Anthropic. And what it was made for is to basically allow AI engines access information through a very simple way. Specifically before, if you wanted your AI agent or AI app to access your Google Calendar, Slack, or any other application, you would have to create a custom kind of like API wrapper to each, which would take a lot of time and it would just not work very well. So then MCP was introduced, and now basically you can connect pretty much any application that has a backend API endpoint to any AI model. So ChatGPT, Perplexity, Claude, your custom AI agents or AI startups. Right. So basically, you can also think about it as the USB-C for AI. The architecture for MCP servers is also quite simple. So there's like MCP host and client, which is basically like an AI model. So something that has intelligence, such as Perplexity again, ChatGPT. There's a data source, so like there's API. So like what data do you want your AI model to access? So Google Calendar, again, Notion, your database, your company's database, and so on. And the main part here is the MCP server, which is like kind of this universal connector that allows the AI model access and understand the data source and use it in your answers. Right, so NANDA and MCP, let me load it. So MCP and NANDA kind of connect to each other. So specifically in NANDA index, we have a whole section for MCP servers that our agents can use. And the agents in our chat applications and in the sandbox that I will show you in a bit can use MCP tools and servers for all kinds of things, you know, to keep track of points, to access specific data, maybe to execute like add something to your Notion or add something to your Google Calendar. Specifically, if you do want to, I mean, half of you already created MCP servers, right? I'm sure you want to share them with the world, and you can do it on the Join39 website. So this is the website that you used to create like agents before. Ramesh showed it earlier, but you can scan this QR code or go directly to join39.org. Once you are in the dashboard, you'll be able to create your agent, but you'll also be able to upload your MCP server, which has to be deployed remotely. So like, just the URL. And now all the agents on the NANDA network will be able to use your tool and access any kind of data you want to share. If I have time, I'll also show it on the real website. All right, so now I'm going to talk very briefly about the NANDA Sandbox or Nest. So this is basically like a test bed that we created to test different components of the agentic web, such as like agent communication protocols, index infrastructure, test how different agents like discover each other and work together in scale of like hundreds of agents. Right now we have 400 agents actually that are distributed all over the world. So each agent is hosted on a separate EC2 instance at a different location, right? We have you know, different regions in US, we have India, we have China, we have a lot of different countries. They talk to each other through A2A, Google's A2A protocol. And they find each other in the NANDA index, which serves as like a discovery layer. And again, each agent has a passport, and that's how they kind of find who they should talk to. So let me go and just show it in real life. This is public, so you can go to nest.projectnanda.org right now and see it. So first, what I want to show you is our agents. So we have a lot of agents on our index, specifically the skill agents. These are the sandbox agents. We have 473 of them, and each agent has like different capabilities. So this is like an example of a passport, right? We call it like agent facts, right? So here you can find everything about the agent. So description, kind of like agent name, jurisdiction, if agent has any kind of certification, so you can see it's certified. When it was created, as telemetry, evaluation, kind of like points, if it's kind of charging some kind of like money to execute something. And then, yeah, so you can kind of scroll through that. These are personal agents. So these are agents we created on Join39. So they'll also be here. Now let me show you our map. So this is all our agents. Every single dot represents an agent in the NANDA index. And as you can see here, agents are talking to each other in real time. So they are exchanging A2A messages to each other. And this is happening again over and over, pretty much every 5 minutes. If you are wondering what they're talking about, you can go to the messages tab here and kind of see that Playmaker responded to recreation. They right now kind of like the questions and answers are pretty short and they're pretty basic, such as like, you know, how do you collaborate with others? What tools do you use? What do you do? But again, since NANDA Sandbox is pretty much open source, you guys can test agent coordination protocols. So you can, you know, make sure that agents collaborate together to execute something or like complete like a very complicated task, write a paper, do something exciting. And if you have an agent, if you have like a company or you're a student that created like an interesting agent and you want to see how it collaborates with other agents, you can basically deploy it on our sandbox. So it's super simple. This is like deployment script. All you need to do is run these commands. So agent ID, Anthropic API key, I'm sure everyone has it here. You know, you have to configure AWS in advance. Yeah, just capabilities. And once you run it, it's gonna basically be deployed on the sandbox. Yeah, so this is pretty much it. I can also, this is like the architecture of the sandbox. As you can see, like what I just showed you is like the front end app, which is like UI that pulls from different databases, like from our index, which is a database, and from our database of messages. And there's a lot that's going on in the backend. Like here, requester agent has like, you know, Lambda domain, it can be OpenAI, it can be Claude, it can be anything. And you know, it has a few components such as like logs. Yeah, this is pretty much it. I'm happy to take any questions. Yep.
Question is how you are going to monitor the runtime vulnerability when agent to agent communication is happening or MCP
This is a great question. So that's why we have like the messages tab here. So how, when an agent receives a message, it actually adds it to its logs file. So it's not naturally like, we can't really intercept it. So what we do is we make it so every agent, whenever it receives a message from another agent, it adds it to the database and we display it right here. So specifically in the sandbox, for sandbox purposes, we make every agent kind of give us the message they received so we can monitor it and, you know, see if the A2A really did happen.
There is no active hard guardrail around connectivity ability.
So yeah, A2A doesn't really have any like security features, I guess. So right now it's like sandbox, there are no bad actors necessarily.
Yeah, we should say that this is also a call for others to participate. So if you're a payment company or a security company, you're an eval company or a particular application like health or legal, or building a toy, like I was mentioning earlier, our goal is for you to come and deploy here. So let's say you're a security company or a agent eval company, come and deploy here. We will give you some real estate. So, you know, you'll have prominent placement, and it'll allow you to, it'll allow others to see how your services work, but it'll also allow you to see how your services are being used by others, right? And so on. So this is really a kind of a playground for everyone to come do that. And to your question about kind of the black box versus the clear box. So these are the clear box version of it, where you can see everything that's going on. But of course, we'll support black box as well as time goes on.
Other questions?
I should mention that even today, as far as I know, there's no single place, there's no single AI agent that has public endpoints. Okay, it's like everybody has a telephone, but nobody has a number, and you cannot call them. So there are so-called millions of agents out there, but it's not a single agent you can call up from your website or from your phone. Everything is embedded in some piece of software and so on. It's like saying the World Wide Web is like LinkedIn. See, everybody has a web page, but it's inside LinkedIn, as opposed to being outside. So there's no public endpoint as far as I know for any agent. So this is the only place right now where you have hundreds of agents with public endpoints and you can interact with them. Do you have some? but can you see them? Oh. Okay, good. Let's do it. Questions, comments? How many of you actually played with the Sandbox and deployed something? Oh, that's pretty good. Excellent. People are doing their homework.
Right, we're gonna have some demos as well about the Sandbox coming up. Yep. So, any other?
Thanks very much, Maria. Next up, we have Will Potter. And let's see a show of hands, who had a slice of pizza tonight? Who had a drink? This is the guy and the company, Natoma, to say thank you very much.
Thanks, Chris. Thanks everyone for coming out. Really happy to be here and happy to support NANDA and the mission of raising awareness around the agentic web and all the development and innovation that happens here. So my name is Will Potter. I'm one of the co-founders of Natoma. We are a Boston headquartered startup here. We're about 20 people around the world. And we are helping enterprises adopt AI, but more specifically, helping enterprises adopt MCP. What I'm going to talk a bit about is how enterprises struggle to adopt MCP and how we help them fix it today. This is a very high level view of how we're thinking about the problem. And at the end, would love to hear any thoughts, questions around things we're missing, things we can do better, because it's such a nascent and exciting problem. What we're seeing with the large companies that we work with today is they have not met the AI moment. They're buying tools, they're buying ChatGPT, they're buying Cursor, they're buying Claude, they're buying all of these really, really large language model tools and not getting as much value as they could out of them. They're not able to connect to internal data sources. They're seeing people spin up connections with bespoke connectors on their local machines, and it's really kind of a mess. And they're very uncomfortable about this rapid shift in technology. So for us, what we're trying to do is help them really deploy this technology at scale and do that in a vendor neutral way where you can buy OpenAI, you can buy ChatGPT, you can build your own model, and then you can connect it to all the other multi-vendor tools that you have running on the back end today. So for employees, that means give me access to all the tools that my company has. Let me connect any agent I want to with these tools, provided it meets security and governance requirements within the company. And then if I'm an IT admin or a security admin, I need to know what's going on so that my employees aren't opening us up to liability. So that's where we come in. With Natoma Agent Access, we are a multi-environment product where we connect to any LLM out there, any MCP client, and then any MCP server, regardless of where it's hosted. And we give you a single control plane and point of visibility into the connections between all of these tools. And we let you manage that from one place. So let me talk a little bit about what that means, because there's a lot of different pieces. And kudos to Maria for doing such a great job explaining MCP. I'm going to piggyback off of that a bit. The problems that we're seeing right now with these large companies is they have multiple people who don't know where to find these servers, but they want to connect to Salesforce or they want to connect to their Snowflake database. They have multiple people building internal servers, and they have people who want to build servers. There's a huge enablement problem right now with these early stage businesses. We also see that they don't know where to host them. And when they do host them, it's often just on your local machine, which doesn't give you clear visibility into what's happening there. And then most importantly, for large enterprises, there aren't data controls and there's not governance around this. So for your sensitive Salesforce data, you can't just have any agent connecting to this without giving your IT admins visibility into what types of data might be leaked and shared outside of the organizational boundary. So with Natoma, we want to give you a clear point of view into this and then let you construct policies to secure this. How do we do this? And this is kind of the fun part about being, I guess, open and distributed is the enterprise. If you're a large company, you have on-premise systems, you have cloud premise systems, you have endpoints running, all of your laptops, and you have people working everywhere. And you don't want to slow your business down for this. The way we're thinking about it is you don't need to run our system in the cloud exclusively. We can run it on premise for you. We can run it on your desktop, and you control it from one single place on the cloud. And then all of those tool calls stay local to the environment where they're happening. We federate out the controls, the policies, and then ultimately just observe and give your admins the visibility into the actual tool calls that go through the platform. I'm going pretty quick here, short time frame, but I'll love to answer any questions at the end. So big points are give yourself agent reliability, auto scale up the servers, and this is maybe less relevant now, but really show me the tools that are allowed to be used, show me the calls that are being made, and let anyone connect anything to it. And at the end of the day, this is what we're seeing enterprises ask for today, and I'm encouraged that it's not being done through ChatGPT exclusively or through Cursor exclusively. People want multiple models, they want choice, and we're hoping we can give that to them. And we hope that anyone else developing tools wants to build with us as well too. So with that in mind, any questions?
So Will, I have a quick question, which
Yes.
is that, MCP servers are not agents.
Right.
They're like API plus.
Yes.
So what does it mean to think like some of the keywords you use, like agent security, kind of like you can't treat them like agents.
Right.
These are MCP servers. So what's the delta between MCP servers, which are basically API plus,
Yep.
and managing them because they're passive, they're not autonomous.
Yep.
They only talk when you talk to them. They're not going to do anything bad.
Yep.
On their own, and their access control is controlled by themselves. They're going to decide who can talk to them or not talk to them.
That's a great point, and that's one that we don't harp on too well in these slides. But one of the new things we have been working on, and we're furiously working towards, is agent identity. So a centralized IDP for agents, and then that allows you to construct security policies based on those agents. To do that, you have to let agents authenticate to you to figure out what they're allowed to do within your company's data boundary. And an agent might leverage credentials from a human, but hopefully it doesn't. Hopefully it's using standalone access given to it by a service account or by an agent IDP. The way we're thinking about it is it has its own identity. It belongs in policies just like a human using ChatGPT does. And when you have that in place, you still need the same visibility and controls and policy generation. So, but it's still very new. And to be frank, we're not seeing a lot of agents being fully deployed in production yet today. We have a couple of customers just starting to connect, agent building platforms and autonomous agents to us for, running data reports, filing tickets in Jira and Linear, trying to clean these things up. And it's really, really new, but the confidence in the quality is still low. So they're very hesitant to roll these out at scale when it comes to their production data. So. Yes, MCP is kind of the leading way to get agents to be able to do more, but they're not going to trust those agents without the guardrails and the visibility in place. And with MCP and A2A support for us is really going to come out in the next few weeks. With that, anyone can build on you too. So it's exciting. But yeah.
So my question is, in your slide was you are able to block shadow MCP.
Yes.
Could you please go a little bit?
Yeah. So we have an agent that runs. Keep in mind this is corporate IT, so they have a lot more control on what they can do. Shadow MCP servers for us are MCP servers that your employees would download and run without corporate IT's permission. The way we go do that is we have a desktop app or MDM scripts that will go update config files for any MCP client on your machine and rewrite those with Natoma URLs if the server is supported and remove them if it's not and if it's banned. So for corporate IT, it's a much easier problem and it's not really one that we would use for, it's not a problem for consumers at the end of the day.
Thank you.
Yeah. Yeah. We have a couple, so the question was, do you support self-hosted LLMs? We're LLM agnostic, but whatever library you're using to integrate with an LLM, it needs to also have MCP support. Because at the end of the day, MCP is our core language today. A is coming soon. But yes, we do support that as long as you have built an MCP integration on the client.
Wrap it with an MCP.
Yeah.
Got it. Thank you.
Yep. Oh, yeah, please. Yes. So the question was, can you speak to how you evaluate the true intent and capabilities of each agent? For us, we don't do that ourselves. We give your company the ability to do that with clear audit logs and identities for each agent and tie them to human users who are interacting with them. And then it's on your company and your IT admin team to set up policies, set up guardrails, leverage things like request context to put rules in place. So if you have an agent, an external agent calling an internal agent of yours with a IP address from a sketchy area, and it's calling you 100 times a second, you'd want to put a control in place. And at the end of the day, that control needs to be deterministic. You can't override that. So we have to have a way to inject some deterministic safeguards here for these agents. But we're not trying to guess at what the capabilities are and whether they're valid or not. That's really exactly human in the loop process. So yeah. Cool. Thank you all.
Thanks so much, Will. And Matt, you're gonna next up. Yep.
Awesome. All right. Can you hear me?
Yes, and so this is to welcome Matt Dionis from Radius Technologies.
Thanks, Chris. So yeah, I've been working with NANDA for, I don't know, 7-8 months now. And it's interesting, the previous talk was about MCP because I spent months building in MCP. We built some solutions that integrated payments through things like X402. We began to build discovery layers. What I'm going to demo quick today is something where actually this is the first live demo and we're kind of announcing it now and officially more broadly announcing it tomorrow. So this is a product we've built called Descendant AI. Let me find the right screen here. All right. So what you're seeing here is just the basic UI of what we call Descendant AI. So a lot of us at Radius were friends and coworkers back in the early Circle days. I worked at Circle for about a half a decade between 2015 and late 2019. So through all of this work with MCP, what we realized is a big missing gap in these, we talk about, like Ramesh talked about, millions, soon billions of agents. A lot of these agents aren't very useful. And they may be useful in the sense that you pull out your phone at a party or a get together and you say, hey, check this out, it's pretty cool. But a lot of the agents deployed out there, you really wouldn't want to use in production settings, making like large monetary decisions. So what we built through our learnings is this application that I'm about to show. The whole backend is built on Rust. It's MCP inspired and it's Anthropic's agent skill inspired, but it's not strictly using any of their SDKs and anything. We kind of built this from scratch with inspiration from existing protocols and what we've learned. So I'm just going to jump right in. This is going to be no slides, just demo heavy. And I mentioned Circle before because our first iteration of this is in the crypto vertical. So you can think of what I'm demoing as an agent that's just an expert in crypto. Specifically, the persona I'm showing here is like a semi-active trader. You're not a day trader, you don't do it for your job, but you move enough money around that you're not going to rely on ChatGPT or Claude hooked into web search to answer questions for you. So First thing to show you in this UI here, I can ask this agent what it can do. We feel very strongly that the first step is these agents know exactly what they're capable. Now, as the LLM's formulating the response on the left here, what I want to show you on the right, and this is a core feature of this application, this is the actual data that came back from the list capabilities call. So it includes everything that this agent is capable of. And not so exciting for this use case, but I'm going to show you in a second where it gets more interesting. So now we have this overview. Looks like this agent can do a bunch of crypto stuff. Let's start it off with something simple here. So we're going to say, what's the current price of Ethereum? And what should be happening in the background right now is the LLM is discovering what skill is best suited to answer this prompt. And then at a lower level, it's saying, okay, what individual MCP inspired tool is best within this skill to answer the specific prompt? And then each of these tools is hooked into external third-party APIs. So the important thing to note here, you deal with hallucinations with LLMs, you deal with them using web search and getting not so great, not so up-to-date data. What we show here is it pulled back this exact price from this CoinGecko source at this exact timestamp. So this is some citation and validation that the natural language response you're reading here is informed by data that you can verify that quickly. So we're talking a lot about MCP. I mentioned X402 earlier. What we strongly believe is that Web3 and a lot of the Web3 primitives are really kind of custom built to support a lot of what we're going to need in this agentic ecosystem. And one of those things is payments. Like, I'm getting this data through CoinGecko. At some point in the future, like either CoinGecko or Radius, somewhere in this flow, there are going to be payments involved. Like your agent is going to have to pay for this up-to-date data. So what we built in from the get-go with this app is when you sign in, we leverage a service called Privy to generate a secure EVM compatible wallet for you. I'm going to refresh this. This demo is running locally. You can see localhost 3000 just on my computer, so there are a few hiccups. But now it called get user info, got me back my wallet address. You'll notice here, we actually generate you an EVM compatible wallet as well as a Solana wallet. So now that we have that wallet address, I'm running all of this on Ethereum's testnet called Sepolia, just for context. So I'm going to say, check the ETH balance of this wallet on Sepolia. And the LLM should be able to leverage skills and tools again, and this is accurate. So it's using Etherscan's API at this point, and it's grabbing me my actual balance there. So I know I have limited time. I'm gonna run through these next few examples pretty quickly. Whether you're in the crypto ecosystem or not, I'm hoping this presentation inspires folks to think about what complex workflows could you support with something like this. I'm a weather nerd, a college football geek, so I would love to build in those verticals. And obviously, they'd be different APIs and different skills and tools, but we feel at Radius that this application we built in Rust, about probably 80 to 90% of the code in the architecture could translate across any vertical. So this is cool here. What you're seeing is that the LLM used the correct skill and realized it should actually call two separate tools to answer my question. So it got both token prices, and then it called this API called Crypto Panic to get up-to-date news about the crypto market. So let me show you just a couple more here. This one, I'm trying to get progressively more complex with these, and this could break at any second since it's a local demo, but it's actually been performing in a pretty stable manner. So now I'm asking for a complete analysis of Ethereum, including price, sentiment, fundamentals, latest news. And you'll see here, it actually chose to make 4 tool calls across 3 different external services. And it got me back all this accurate, up-to-date, context-rich data. So, couple more. One I think is cool here is, for transparency, the address you're seeing here, this OXAB58, this is Vitalik Buterin's Vitalik.eth address. I'm using this for obvious reasons. When you're asking to show the complete portfolio, a lot of the addresses don't have much. His is loaded with NFTs, DeFi protocols, balances. So this is a really interesting one to look at. The latency you're seeing here is simply because this call is pulling back a ton of data. And then even once the data is pulled back, the LLM will have to reason over it. So we're going to give it one more shot here. And if not, we'll move on. I believe when I'm running this on locally, to give folks an idea, is a llama model that's 20 billion parameters, so not as heavy duty as a lot of the 100 billion plus parameter models, but it still performs really well. And you see here on this second try, it pulled us back all of this interesting information about Vitalik's main wallet here. And you can see why it took a few seconds. This is a lot of information that it's pulling back here. One quick thing I want to show before I wrap this up is we did build in some really cool UI features. So we have slash commands. You can do things you normally want to do, clear the current conversation, log out of your account, compact the conversation. What I find cool is you can kind of skip the mapping to skills and tools step and reduce the latency and reduce the token usage a little bit by using one of these slash commands. So the next prompt I'm going to fire off, I know for a fact I want it to use this analyze market skill. So I'm going to prompt it with that to give it a hint that you should use this skill. Don't bother trying to determine the skill. And you see that comes back much quicker. And that's just pulling back the correlation matrix between ETH and Cardano. And as I wrap this up, I'm just going to fire this very last one off. And it's just asking for the total value locked in Aave. And this is yet another integration we have. And this is really just scratching the surface of what we've built out here and what we can support. But what I'm hoping this inspires folks in the audience is to start thinking about, within and outside of crypto, what long-running multi-tool complex workflows could you support if your AI agent, through this MCP and agent skill inspired architecture, could have access to any APIs you want? The way we look at this is, what I just demoed is thousands of dollars a month worth of API subscriptions. We feel strongly that even if you're not willing to pay for those subscriptions, there should be a way through micropayments for your agents to always have access to this quote unquote premium data. And that's what we're trying to show here. So yeah, that's about all I had demo wise. And if we have time, I'd love to take a couple questions.
Thanks very much. Thanks very much, Matt. Is Ryan Fox in the room? Yeah, great. So can we defer questions in the interest of time? Can we defer questions to Matt's colleague, Ryan, once we finish the presentations? And sorry to cut you short there on that, Matt.
No, that sounds great. Thanks a lot.
Thanks very much for sharing some incredible progress there. Next up, I'd like to invite Amanda McDermott from Coinbase.
Oh, do we need to change the? Hi, everyone. I'm Amanda.
I work on the X402 team at Coinbase, and the last presentation was actually like the perfect tee up for my demo, but it's on my computer, so I can't actually show the actual demo, but you can come find me afterwards and I'll show you. But yeah, that's good. So yeah, so I think it was Matt just now was mentioning X402. Has anybody heard of X402 here? Okay, so some people. So we'll do a brief rundown. So X402 is a new open payments protocol based on the old 402 HTTP endpoint, which means like error, which means payment required. Back in when the internet was like invented, there was no way to do payments, right? And definitely not micro payments. We can do credit cards, there's fees, but with X402 using stable coins, you can make teeny tiny payments and a bunch of them. So yeah, so with today's tooling, right, literally Matt just said, imagine if you could call any endpoint, any API you wanted without an API key, you could just do whatever, get what you needed whenever you needed it, right? Let your agent go nuts and like figure out what it needed on its own. Right now, right, normally you need to get it, you need to sign up, you need to like evaluate payment plans, you need to like get an API key, you have to like put it somewhere safe, right? You have to use it. And that's for every single data source and endpoint that you want to use, right? So imagine if you didn't have to do that anymore. If you, so what X402 does is if you set it up, like if you gate your endpoint, right, with X402, that means anyone who comes to that endpoint, you can say, I would like some money, please. You don't have to sign up, but you have to give me like a cent. And then I'll give you this like CoinGecko data, whatever, right? And you can imagine the possibilities for something like, you know, the demo we just saw. Imagine if it wasn't, you didn't have to like map this tool to this thing and this tool to that thing. It was just like, you can discover whatever's out there and you can pay for it and you can just go nuts. So, yeah, so you can, so right now, there's like LLM inference, there's compute, there's a lot of data feeds, right? Market information, long form reasoning. So, and this is going to lead into my demo, but it was like, you know, let's abstract away all the gory details and use our agents to do all the stuff we want to do. So we released a product called Payments MCP, which literally gives your agent a wallet, right? It is a non-custodial wallet. It is yours, and the thing runs on your computer. So when you start up Claude or when you start up Codex or whatever, this little companion app starts up on your computer too. And it is an Electron app that communicates with your like, let's say Claude, right? Talks to Claude, Claude talks to it. It talks to, through MCP, uses an IPC bridge, and then talks to a remote secure wallet UI. So this is the part that's on your computer. And this is the part that's hosted and like stores API keys and does all the security stuff with, you know, our like a Coinbase level security infra. Yeah, so demo time is on my computer, but basically I'll describe it to you real quick and then I'll take questions. But basically you would like go to Claude, it would start up your little wallet app, you'd log in with your email. Ostensibly you would, you know, put money in it, maybe like $1. You know, most things cost like a cent. And my favorite prompt to demo right now is saying like, using my horoscope and like the latest crypto AI news feeds, go on Polymarket or find the stuff on Polymarket, the top events, like prediction markets, and evaluate what I should bet on and how I should bet on it and explain why and be concise. And what it will do, it will look through the discovery layer, which we have set up on our facilitator, which is the message relay layer. And as an extension, anybody can run a facilitator, anybody can run a discovery layer. So that's actually pretty cool. And So it'll say, oh, there's a horoscope endpoint. That's a sent. I'll get your horoscope. Oh, there's a like news feed endpoint. It's a sent. I will get that too. And then it'll say, get me the most degen trending events on Polymarket, and that's 1 cent, and I will get that. And it will have all this context now, and it will think really hard and give you an answer and say, you should do this because the stars said that it's a good idea to make a bet on whether the Fed will raise interest rates, right? And you can do that with anything that's available on the discovery layer. Anything that is X402 enabled, your agent can now get the data and do stuff with it. And it is really crazy to watch. And like you, again, like Matt was saying, I'm really curious to see the long chains of tasks that people throw at it and what it can do. So that's it. If you want to see the demo, you can come see me afterwards. Do you have any questions? Okay. All right. Thanks, everybody.
Thanks very much, Amanda, and really appreciate the flexibility with the timing. And so just to like put up, we've had Radius very quickly. We've had Radius and we've had Coinbase talk about these real small payments. Kind of what does that mean? So those are available now. But think about what we have right now. What we have right now when you're accessing an ad-supported web page, when you see that static display ad, those go for something like $1 per 1,000 impressions. So if you've got 10 ads on there, you've got $1, so you've got 100 cents. You've got 10 ads on there, then you've got a 1 cent charge. Essentially, the industry is leveraging there to help pay for this knowledge from the website to come to you, from the publisher to you. So that's kind of the economics of that. About half of that will go to intermediaries. About half of it will go to the publisher, the owner of the information that's providing that information to you. So all of that, and that's just for static ads. And so when you are accessing information in new ways, and we're talking about some of these small payments from Radius, etc., through Coinbase, like those types of really small payments, each of those doesn't sound like much, but when you look at it at the scale, in this case of advertising or basically paying for access to data, then it can just kind of puts that into context. And so real briefly now, we're moving on to what's going to have to be a rapid fire showcase. And so we first, as we enter the showcase, so just kind of I wanted to keep in mind kind of the theme of tonight was MCP night. And so kind of how is MCP being used already by the projects that are being showcased, or how could MCP add value to if they were to incorporate into it? And so first up, we have George. Thank you very much. Round of applause for George here.
Thank you. Good evening. My name is George Hu, founder of DunBack Meadow. DunBack Meadow is a decentralized marketplace for AI agents. It's going to be an economic layer of the agentic web. So AI developers develop their agents, then list in the marketplace. These agents could be a personal agent, which interface with humans, and MCP servers and other agents, like skills agents, resources agents. And the users come to the marketplace, then license the agents, then customize it, and they use it with the DunBack Meadow mobile app. DunBack Meadow incorporates the NANDA protocol, which keeps the agentic web open, as well as establish an open standard, a common language for all the agents to talk to each other. The protocol has this standard agent fact schema that exposes endpoints for every agent and for other agents to communicate with. So this is already explained to you, so thankfully. So the X402 protocol will be ideal to handle the transactions and payments between AI agents. DunBack Meadow incorporates NANDA protocol as well as the X402 protocol. Basically, the platform serves as the facilitator to take care of the payment transactions for the AI agents and MCP servers. You can add the MCP server to the marketplace by coming to the platform and build a skills agent. You specify the LLM and specify all the tools. As soon as you build this agent, the platform will create a crypto wallet for your agent. And the agent will use this crypto wallet to receive and send payments to other agents. So any agent uploaded to the marketplace, NFT will be generated and sent to the owner's wallet. And this NFT will represent the ownership and IP rights of the agent. The agent's identity is tied to the owner's identity by the owner's crypto wallet address. And all the licensing transactions and the agent core transactions are handled by a smart contract on the blockchain. The agent creator, the owner, specify the licensing agreements and agent core agreements when they initially list the agent on the marketplace. And it's permissionless user login, very easily log in with the email, so no sign-ups. There are two ways for AI developers to monetize their MCP servers or agents. One, connect the licensing fees from end users. And two, connect the fees from other agents on per call basis. Our users can talk to their personal agents very easily with the DunBack Meadow mobile app. And your personal agent will call other agents either in the marketplace or from outside, depending on what the skills and what the functions they need. And you can personalize your agent by changing his or her avatar image or video clip, by changing the voice, by authorizing it to access your email account or bank account so that he can handle your emails on your behalf and also handle your expenses on your behalf. You can imagine when billions of agents interact with each other on the internet, security could be a big issue. So DunBack Meadow allows the owner of agents to set the terms, licensing terms and agent call terms, which demarcate clearly the responsibilities of the agent owner and the agent users. So all the payments are peer-to-peer, settled on the blockchain with no third parties. And every transaction between the AI agents and humans and agents are recorded on the blockchain and they're transparent, can be traced. Because it's peer-to-peer payment on the blockchain, so the platform does not custody users' money. And any security issues from agent transactions can be traced on the blockchain. So thank you.
Thanks very much. Next up, we have Blake.
So I'm probably the least technical person in this room, definitely to be presenting tonight. But I threw this together with one of my friends, and it's my money, my data, because I think one of the really cool things that NANDA enables is a lot of democratization and access in a really awesome way. And so that's kind of what this idea is all about.
So the problem here we have is that the big tech companies are making billions off of your data because the market is so monopolized and because it's centralized and you get nothing out of it. And wherein we come in is this technology helps you get the market value of your data, and you can, make way over $150 on this data, which might help you cover your car payments. And if this has context, you can make so much more money on this data that you have. And that's how we're doing this.
So to elaborate more on kind of what this idea is right, like I was talking to somebody a while back at my first NANDA event. I feel like every time I show up to one of these things, I learn a little more about what NANDA is and get a little more confused. And essentially we came up with this idea where you could sell your healthcare and or your data of your healthcare to healthcare companies in a way that was kind of anonymous and could help them learn things that they wouldn't be able to get that information otherwise. And so the idea here is if someone's non-technical, right, they can't really participate in these conversations we're all talking about. So it's to build them a simple interface that kind of shows them the value of their information, right? Google collects a bunch of information about us, but we have so much more, and that information is incredibly valuable. And it allows us to, the system that we're talking about here would allow you to connect that data into a MCP server and essentially kind of tell you what some of these microtransactions and how this is working I'm learning about today that might enable this to kind of, take in this collected data, then build kind of a persona of you with your information. Maybe it's location data, maybe it's how you shop, how you make decisions, et cetera, et cetera. And when another business agent is coming in and it's looking for information, maybe it's trying to figure out how to validate their new prototype and they need to ask users questions. Well, this kind of persona that we've built would allow another agent to interview that agent paid, and then you put that money in your pocket instead of it going into the pocket of a big tech company. And for all the other businesses trying to figure it out, they get access to data that right now very few companies have access to. And I think what's really cool about this is what NANDA is all about. If you ask me, this is what, all of these technologies and these mini agents are enabling is a bunch of normal people to be able to participate in a global world in a way that was limited to so few companies. And so this is kind of what we thought of and what we're thinking about with kind of how to use NANDA. So yeah.
Thank you very much. Thanks, guys. Next up, we have Diego. Brownie points for being on the front row.
Yes. Hi. Hello. Well, check. Okay, here. Well, my name is Diego Mache. I am the co-founder and CEO of Lolos.AI. The acronym means LLM, Orchestration Layer Operation System. And it basically helps the businesses right now. All the business and enterprise are using, the employees are using ChatGPT in a manner in what they can take some documents or they have some integration or some MCPs. For example, they can use SaaS. There are a lot of SaaS and applications that has already integration through MCPs to the commercial tools like ChatGPT or cloud. But there are some most of the businesses right now, they have in-house software they create, or there are a lot of software that is out of all this sphere, right? They don't have an MCP solution, right? So the idea of Lolos is help through we are helping our customers through our platform to rapidly integrate AI LLMs to their applications. Basically, we are doing that using MCP, Multi Context Protocol. We have been working with this platform from a year. We are 11 right now in the business. And basically, the architecture we are using is we have a microservice stack architecture in what we already have some templates for some businesses that we realize that are, for example, retail, logistics, and healthcare. We have some businesses there that they already have some applications that have their particularities. So we have deployed from them some features in this to integrate the agents. So basically, the platform we have two features. One, we enable our customers to create AI agents they can create the system prompt, they can put the wide race, and they create a small workflow. And the other, we have another feature which is basically they can create a document with a Canva feature in what they can go through the document using human in the loop and iterate on it and add more information and features on the document. Well, basically using MCP, here are some pros and cons we have been detected. At the beginning, we have much of the people probably here that are using those tools. We used to use triggers and APIs to call, but then we realized that using MCP, we can have this feature in what we can reuse our agents. We can deploy the feature and then reuse this feature through different agents. Well, here is one of our customers, Security Advisor. In this customer, we have here a use case in what they already have an AI SOC agent, and they expose us MCP. Here we detect one of the cons that we get from MCP, that you need to implement. We hear for this customer, we need to implement the layer of security that is right now in the tool. And basically, we gather information from feedback from the customers, and we use this MCP to add more information in the report creation and stuff. Well, Surupark is another customer in what we have been deploying this kind of features. Here we have they already are using, so we are already using some features from HubSpot, for example. In this case, the customer is using the HubSpot MCP, and we have another CRM and ERP that we create this feature. So basically, the strategic value that we are giving our customers is this opportunity to orchestrate different agents, then transfer information, the context, and then the collaboration. This is something that we are getting from the MCP, and the enhancement, sorry, of the applications they have right now, right? So I don't know, some question? Yes.
Roll on through. Thank you very much. Thank you very much, Jacob. Next up, we have Daniela. And so who's just in between, who's heard of 996 in the context of startup entrepreneur type discussions over the last couple of months? So good. So 996, there are some very popular tweets, etc., from Harry Stebbings, who does the 20VC podcast. 996 is like that's his definition of what it means to be an intensive founder. So you're working from 9 in the morning till 9 at night, 6 days a week. That's the type of profile, the minimum type of profile that he's wanting to invest in. And so that's how intense life can be for founders. When we believe collectively in the agentic future, 996 is kind of blown out the water, right? Because it's 24/7. But there's one place on earth that is not even doing 24/1, or it's not even doing a single hour at the moment. And that's down in DC with the government shutdown. Here we have the replacement.
Hey guys, I'm not here to replace the US government, but we have been building, but maybe. I'm Danny, or you can call me Daniela. I'm the CEO and founder of WippAI. Just graduated in May from Harvard Business School, and I had the privilege of start building this here out of the MIT Media Lab, so right next door. Let me take you guys a little bit through what Wipp is and what we're doing. So like everyone can relate to this problem, I think. Essentially, in government, influence networks are hidden and they leave institutions reactive to government change. This means that whenever there's policy movements going on, a lot of businesses, a lot of people just don't know exactly like what's happening, how that's going to have effects in the market economy or in the society. And it's a huge problem, especially for corporations, especially for businesses that are just trying to live and adapt in an ever-changing political world. I imagine with AI, this is only going to get worse as the government one day wakes up and starts saying, hey, we need to do some regulations on AI, and knowing what that's going to mean for people is going to be increasingly more and more important. And the reason why it's so difficult to do this today is because data sources are so scattered at the government level. If you wanted to look at what kind of policy is happening in Oklahoma, you have to go into a completely different database than the one in Florida, than the one in Texas. And then when we get into the federal level, every single federal department has also different databases, different stakeholders. And I'm saying a lot to basically tell you guys it's complete chaos. So what we're doing at Wipp is we're turning all of this complex political data into actionable influence strategy. Our goal is legitimately that, give you actionable steps to influence the politicians, to mobilize your own agendas. And we're doing this via digital twin simulations of those politicians. Going back a little bit into NANDA, we have created agents that essentially are encoded with a politician's own political identity, their priorities, behaviors, who they tend to vote for, how they tend to feel about certain issues. And we're detecting those behaviors over time. So it's not just present behaviors, but also we're mapping how that political discourse for each individual has changed throughout the course of their political career and how that has moved and affected policy as time moves on. And what we're doing too is pairing that with the holistic picture of the landscape in which they will affect in. So constituent data, coalition patterns, which I mentioned, economic data, to be able to give our users first and second, third order effects on how policy may be impactful and preemptively get ahead of the game and do something about it. So to just go a little bit deeper into those agents, we're mapping individual networks of influence through the evolution of their political discourse. So a bit if you think of like LinkedIn, the first, second, and third order connections that we all have on our files, we're doing this for the politicians too, based on people that they interact with. So other politicians inside right now of Congress and Senate, but as well how they tend to feel and behave on certain issues. And we run these through regression models and assign them weights to actually get a very personalized prediction of how this person is likely to vote and act, move with their parties or not with their parties. And with all of that, we relate those insights back to companies. So what can they do with these insights? When we yield these precise and instant reporting on the lawmakers' movements, they can prepare educational materials. A lot of times it's simply about a lack of education that the politicians have on how certain votes will affect their districts, will affect the economy that their constituents work in. So by giving them real insights, our clients, whether it is government affairs professionals or lobbyists or advocate groups, can take it directly to the politicians as data-driven educational material. More so, they can strategize. So by forecasting how these effects will go, by forecasting the likelihood that a policy will move into being enacted by law, you can strategize preemptively inside your own business, priorities to prepare for that. And I think most importantly, since you have like the strategy, you have the materials, you can go out and actually mobilize. You can interact within our platform and build those coalitions directly inside of Wipp that are going to be supportive in whatever priorities you have. And right now, what we have in the platform, we've actually started using client data to really understand what the priorities of certain clients are, and then matching that with our insights of Wipp. So every single influence strategy is completely tailored to the specific priorities that you have. Let me bring in MCP a little in here. We're also integrating with people's calendars, outlooks, with their own directories at the legislative level, so that you can send those communications and you can schedule those meetings, track those mobilizing efforts directly from our platform. We are live, so we have a product that's functional and working today, and we are looking for any small businesses, lobbying firms, government affairs professionals, or advocacy groups, that includes NGOs, that would like to join in our beta program and join the current clients that we have. Super excited to be able to share this with you guys. And if there's any questions, let me know. Thank you.
Thanks very much, Daniela. Next up, we have Nicholas. After that, we've got Nitin and then Team Northeastern. Is Nicholas Luter here? Okay, we'll move through to Nitin.
All right. Hello, everyone. My name is Nitin. I'm co-founder of Agent MP. It's a marketplace of AI agents for businesses to find, buy, and scale AI agents. So one of the, why did we create Agent MP? It's one of the challenges for a lot of companies is they are spending from months and even quarters to find the right AI agentic solutions, partners, and products. And we are trying to basically simplify this process through a curation, a curated marketplace where businesses can find trusted partners. They can find, they can basically shop confidently. They can find the agents and with a high level of curation. One of the services that we offer on our platform is a human in the loop service. So here, right? So I'm going to demo quickly a semi-autonomous agent, essentially, using our human in the loop MCP service. And sorry. No video. Okay. I'm going to just talk through the video and we'll kind of upload it subsequently. So basically, what we offer on the platform is this service, essentially, and any agent on the platform essentially uses MCP protocol that can be communicated through a variety of different channels. Customers can, or users can essentially sign up on our platform and can subscribe to any of the channels using their preferences, whether Steam, Slack, and so on. And we also have the service where you can essentially authorize the agent to basically escalate at any point. For example, let's say you have a booking agent and you give some kind of criteria for it to book hotels. For example, certain budget, certain price, and certain kind of star rating and so on. And if the agent is not able to find those appropriate hotel, at that point the agent will basically invoke the human in the loop through this human in the loop service, and the human at that point will be able to basically accept some of the recommendation that might be coming, or reject, or might be able to even modify. So, for example, they can say, change the criteria of your search, expand your search, and maybe find a hotel which is in the a bigger radius than was originally given in the scope, and then the kind of agent will further expand the search and find the right solution. So this is just one example of an agent where it's interacting with the human in this loop MCP server, but essentially it can be applied for any kind of agents, and we actually have this available on GitHub for free to use, and we'll share out the link to it for folks to try it out. So yep, if you have any questions, please feel free to contact us at ops@manifoldsystems.ai. Thank you.
Thanks very much, Nitin. So to close us out, we'd like to invite Team Northeastern.
Hello, everyone. Good evening, and thank you for staying up till here. So I am Tanvi Kadam, and on behalf of my entire team from Northeastern University, I would like to present you our project, Understanding Multi-Agent Architecture, where we have built like 2 working agents. One is the MBTA commuter agent system, and the other is Flash Flood Crisis Response System. So we have used MCP to integrate those, and we have used NANDA for like powering our agents with within the system. So our workflow goes like, we'll be showing you our registry front end, and then we'll be showing how we integrated the MCP for our agents, and then we'll walk you through our demo, how A2A communication is going between the domains and everything. So I would like to hand it over to Tanvi Kurade to like walk you through the first use case, that is the MBTA commuter agent.
Thank you, Tanvi. So, hello everybody, I'm Tanvi, and our first use case is MBTA trip planner. So we are using the MBTA API keys to retrieve the real-time GTFS data from MBTA.
And our agents are working seamlessly to plan a trip for everybody. So for example, if you see, this is the demo, the live demo of our UI. So if somebody clicks on all alerts, it gives alerts for all the routes across the MBTA system. Next. It also shows you the time and the affected stops and everything. So if somebody wants to just put in the starting location and where they want to get off. So for example, if somebody enters Kenmore and airport, it is giving the multi-line stops as well as the transfers. Next, please. And if a layman wants to use our software, so here they can simply ask like how to go from Boylston to Park Street. And here our agents just plan a trip seamlessly, and they also let you know, guys, the stops and everything. So to walk you through the another UI, I would like to hand over the presentation to Kishan and Priyanka. Thank you.
Hello, everyone. So the second use case is flash flood emergency. So we have built 10 specialized agents in coordinating for flash flood emergency through A2A connection and also some communication. And the 10 agents don't have any central control or message broken. They're just like communicating through the NANDA registry. And also coming to the 10 agents, we have divided the 10 agents into 4 tiers. So one is detect, analyze, respond, and coordinate. The detect, it has 3 agents. The 3 agents get the data from social media, environmental sensors, and newsfeed simultaneously. And coming to the analyze, so the analyze tier has 3 agents. It's divided into 3 parts. The first one is getting the, so the analyze, so they basically analyze through different APIs like Twitter and Facebook. And coming to the respond tier also have 3 agents. It's basically divides, automates the response to emergency services and public alerts. And coming to the coordinate tier has only 1 agent. It's called mission control. It coordinates all the 9 agents. And the whole process takes approximately 40 seconds. It's much more faster than the traditional process or the traditional services, which takes up to 45 to 90 minutes. Yeah, we have the agents are all deployed and they are live, and you can see them in the NANDA registry. Thank you. I'm passing on to Priyanka. Thank you.
Thank you, Kishan. Right here, we've built a front end for our flash flood emergency AI that coordinates all the 10 agents using NANDA protocol. So it's basically a React-based web application that connects our Linode server to WebSockets, which enable the agent communication. So in the interface, right now, you can visualize how the agents communicate with each other during emergencies, like the messages, the task flows, and how the decisions are taken. This actually enables to identify bottlenecks and to correct the NANDA protocol. As you can see now, when an emergency alert is created, the agents communicate with each other, they plan routes, they plan routes, and then they generate the action plan. So here, what we're actually trying to do is, when an agents take, normally when it takes a lot of time, we're trying to get it under 30 seconds, which is way faster than the traditional approach. Now I'll pass it on to Neha for the registry front.
So hi everyone, this is Neha. So as you can see, the Maria has and the NANDA has built the registry for themselves. We are the Northeastern people, we build our own registry, and I'm going to talk on that. So on that, this is a short demo which we have created. So it has all the health status and all the 15 agents registered as of now. And it shows a passport, like the agent facts, which we say. So it is running on Linode currently, on the Akamai's Linode, and it is pointing towards the MCP server we have built, which is for tonight. And if we go forward and again come back to our registry, you can see all our agencies has a filter. And if we click on that MBTA, it will directly go to our MBTA server, which is there. So yeah, now it's time for the night, which is for today. It's like MCP, which is going to talk by Anjali. I would like to hand over.
Hi, as you all know by now that what's MCP is. So MCP is an emerging standard that enables LLM to, invoke or discover the external agents or, tools in a standard way. So this enables by wrapping our registry, as a MCP server, this enables the LLM with the three core capabilities, which are automatic tool discovery, standardized invocation, and growing ecosystem. So let's just understand this using an example. Imagine that if an user asks LLM that when's the next train from Northeastern to say downtown crossing. So without MCP, the LLM might not answer it well. We might not get an accurate result. But with MCP, the LLM queries the registry. It discovers that there's an MBTA agent registered in the registry, and then it invokes the routing function, and then it will give the accurate answer. So in a nutshell, I would like to say that MCP transforms our static knowledge answers into dynamic orchestrators of tools, like enabling real-time answers. So now Mani is going to show you guys the demo of MCP server.
Hi everyone. I'm gonna walk you guys through the demo of our MCP which we built. So basically, this MCP server is deployed in Linode instance and it is connected to our registry. So I'm gonna walk you through in a simple two-terminal technique. So the first terminal, I'm deploying starting the MCP server. So I'll get the IP for the server and I'm gonna use it in the second terminal. So I'll be providing my MongoDB URI and my Anthropic key. The cloud is gonna be the orchestrator in the MCP server. So once I start my external MCP client in my terminal 2, it's gonna open the interactive chat. We didn't build a UI yet, so it's just the terminal for now. So once the interactive chat is on, the MCP server will work as a registry, and we can query the available agents in it. So using that query, you can see the registered agents, which is in, the available agents, which is in our registry. It's going to show you all the agents. So these are the 15 agents which is deployed in our registry right now. So you can talk to it directly in any way possible. So here comes some example queries. So the first one will be, I'll be asking if there is any public communication agent. So the cloud is going to look into the registry and going to find out and give you back the registry ID, URL, and the location and agent facts. So this will be useful for the A2A. This MCP will give you the agent URL to one agent which is necessary. That agent will use this URL to talk to the another agent. So basically, we are passing the endpoints. So I can show you one more example. Like I'm directly contacting the MBTA agent and asking it, how do I go from point A to point B? So it's going to give you the route. In this case, I will be asking airport from Kenmore to airport via train. So it's going to give you the result using the MBTA API. So you guys don't have to worry about the hallucination part because Claude is not giving you the answer. Claude is just putting the JSON info in natural language. So the MBTA API is giving you the answer. So next, at last, we can look at the last example for A2A. So I'm going to ask, so I want to ask a question to agent B, but I'm not going to ask it directly. I'm going to ask agent A to pass this message to agent B. So I'm asking the public communicator agent to send this exact text of what are the alerts available right now in, let's say, Kendall Station or anywhere.
So this agent is passing that exact message to the news alert agent, and it retrieves the answer back and gives it to the MCP server. So Claude is basically acting as orchestrator here. And you can see via this demo, you can see the MCP working and A2A working together. So with this project, we see MCP is like a complementary to A2A. That's it. I'm passing it over to Sharon.
So just to wrap everything up, we're working with MIT and NANDA as Northeastern capstone students. So we used part of their registry to first understand, like we used the nest, that's why we started. And we have accomplished that now by connecting it to the MCP server. And whatever you just saw is the perfect demonstration of that. And to top it off, we built real world use cases that address challenges that we see. Like a crisis response system is a perfect example of how AI agents should collaborate, right? And an MBTA agent, like, come on, we're all sitting in downtown right now, right? Aren't we? So I took the red line today, so, and the commuter. So yeah, we're addressing real world problems day by day. And to conclude, we'd like to extend special thanks to the principal investigators, Dr. Hema Seshadri and Dr. Ramesh Raskar, and Akamai Technologies for hosting their Linode hardware for us. We're students, so we need our professors to graciously contribute a little bit. And our Akamai mentors, Dr. John Zinke and Yavi Vindas, whose guidance has brought us thus far. And MIT contributors, Dr. Pradyumna Chari, Aditya Sharma, and Maria Gorskikh. So thank you all for being a patient audience. And if you have any questions, yeah, we're ready to take some.
Thanks very much. And just to wrap it up really quickly, kind of thanks so much for coming. We've got A2A night coming up early December. As we look ahead to what's next, keep an eye and subscribe to the Luma calendar. When we think back at the last 12 months, there's a lot that's happened over the last 12 months, to mention just a few small things, apart from NANDA. And the next 12 months, there's people in the room, people outside of the room, the things that we need to be solving. And very briefly, kind of this is the first meetup for the Boston chapter specifically. We've got lots of areas we're working on. Lots of people have put names down to be involved. In addition to that, we've got Rowan here that's come in to help again with the project. We've got Shantanu at the back, I think he was, and lots of work going on. You'll see communications coming out for this. I think about this as what applications ultimately, what applications are going to be out there to help decide which businesses are going to survive. If you think back 10, 15 years, what did a map look like? Kind of you wanted a cafe, you could find the street, but you couldn't find the cafe. Now it's obvious to us, right? If you think about the same version, which cafe locations have agents that you can talk to? They might be MCP augmented, they may not, but which of those have agents and which of them don't? Which would you put your money on still being in business in 5 years' time? That's the way I think about that. Next big agentic thing for consumers, just kind of to highlight this, if we had time, we would have done that more kind of whiteboarding, etc. But essentially, we're all trying to think, or a lot of us are trying to think about what's that next big consumer app? What's going to be the agentic case that consumers say, you've got to have this, it's brilliant. Just click here and it's done. At the moment, that doesn't really exist for people. There are some use cases, in my mind, there are use cases that are very interesting, but maybe use cases like kind of going on holiday, or kind of something that people do once every 6 months or whatever. I think we need to think of a daily one. What I'd love to do with the whiteboard session, probably another time now, would be kind of think about what advertising segments there are, just as a way of segmenting people, age, behaviors, etc. And what do each of those groups do? What are the daily activities? Kind of how do they differ by group? And then how could that be augmented from the agentic session, agentic approach? So kind of brainstorming that is on the horizon. And then just to close out, just leaving the QR codes on here, different ways to be engaged. And obviously this is a community effort. So thanks very much. Thanks again to Akamai for hosting us here. Tremendous location. Thank you.
I want all of you to go right now before you leave. The central one opens a LinkedIn page, and underneath write your own company, your own description, what you did today, or